source.com for doing our interview with us.
Appreciate it. Thank you.
So I'm Jason.
Jason Alex.
Wanted to get it to you before things got crazy after your talk. So hopefully I'll catch up with you afterwards too.
Yeah, definitely.
So I was just going to read off your kind of quick bio side, if that's fine, unless you had anything else you wanted. And I'll give you like a 5-minute warning. I'll be here at the front, so I'll just like flash 5.
It's not available on how to get the switch to...
Should just switch over. Hit the, try hitting the button. There is. Is that you?
Yeah.
Perfect. Okay. Alright, looks good. Slides done, supported done. Get a nice shot of that so I can download while you're doing your thing. So I just, good. And you can clip this wherever you'd like, and it just kind of goes over your ears.
Is it on?
Yes. So we'll give it like maybe 2 minutes or so.
Works out? Cool. Okay, cool.
Or are you gonna leave that up?
No, I will get started in a second here. Yeah. No, they'll be able to go to their laptops or tablets and kind of do the same thing. Yeah. Yeah, slides are online. There's all my junk. Yeah, walking in like that, I'm like, that's weird. See, you see a picture of yourself that large, I'm like, ugh. Is it being recorded at all or no? Okay. Is my range, can I walk? Because I don't stand up here usually. Yeah, okay. So I'll probably walk down there.
All the other note too is if you do questions at the end, if you repeat the question before you answer, because then it'll pick up better on the recording.
Cool. Let's rock and roll.
Good morning, everybody. Welcome to the first talk of the day in the sysadmin talk. Feel free to cozy up and make some new friends. We have here today Alex Juarez, a principal engineer at Rackspace, and wasn't paid to say this. He probably doesn't know I'm going to say it, but we are users of Rackspace at our company, cloud sites and servers, and you guys have pretty awesome chat support, so good job. Been with the company for 8 years. RHCA and RHCI enjoys all things Linux, crafting killer cocktails, so find him at the bar later.
I forgot that said that.
And finding the best spot to drive in San Antonio. He's doing a talk today on Your System Calls in You, a brief exploration of using strace. So I'll turn it over to you, Alex.
Woo! All right. That is not needed at all, but thank you. Thank you. All right, so the slides are already online and ready to go. If you bring up the URL there, slides.unsupported.io/explore-strace, at least when you're looking down at your laptops, checking your email, things like that, I always think you're looking at my slides, so it's helpful. If anybody wants them, anybody got them, we'll leave it there for a few seconds more. And cool. All right. If you do bring them up, the cool part is as I go along, we will follow along with me, okay? So, like I said, Your System Calls in You, a brief exploration of strace. I don't like standing up there very much. There's demos at the end, I'll come back up, but usually I'm down here walking around. It just makes it easier for me to kind of go through this. All right, so first off, hello. And I think a lot of people don't start off with at least hello, right? So hello, my name is Alex Juarez. I wasn't expecting an introduction, so that's why this slide is up there. I wasn't sure how the audience would sympathize with Adele or Lionel Richie, so they're both up there, right? So again, hello. And also, thank you for coming out. There's a lot of great talks at this same time slot, some that I wanted to go to. It would just be weird if I didn't go to them, or I didn't go to this one instead. So thank you for coming to this talk. Thank you for spending your time with me. I really do appreciate it. My goal here really is to entertain you long enough to learn a little bit of something. Hopefully you walk out with a little bit more knowledge. Hopefully no less knowledge. That would be weird as well. So how we're going to get there, right? Our agenda for today, kind of the topics we're going to talk about. First, we're going to talk about why this topic. Why spend 45 to 50 so minutes talking about a very simple tool, very basic topic. Then we'll talk about what is strace. The experience level in the room can probably vary from 10, 12, 15 plus year admins to 2 or 3 year Linux users. So I want to get also on the same page on what strace is, the same lingo, the same jargon, okay? And we'll talk about system calls, which are kind of the core of everything going on here, and kind of the meat of it. After that, we'll do some demos, because what's a presentation without demos? The chance that things go horribly wrong. It's always fun. So far so good. Wi-Fi works, this is working, so that's kind of cool. Then we'll do continued learning. I can't show you everything about strace or about anything in 45 minutes or 50 minutes, right? It would be impossible to really cover everything. So what I'd like to do as part of my role at Rackspace, as part of my role here, is to get you enticed just enough to go out and learn a little bit more and give you the tools and the opportunities to do that in an easy fashion, right? Make it easy for you guys to learn more. Make it easy for you guys to go out and just pick up more information. Lastly, we'll do some Q&A. And by the time it should be lunch. So here we go. So why this topic, right? Again, why spend 45 minutes talking about strace? For me, it's two things. The first thing is about solving problems. At Rackspace, one of the things that we do is, one of the unique things that we do in a managed hosting environment is that we get to see thousands upon thousands of configs every single day. While most people have environments where they run 10, 20, 100 plus servers, most of them are the same. Most of the configs are the same. They know what's running on them. At Rackspace, in a managed hosting environment, we have thousands of configs every day, running everything from your normal LAMP stack, right, very basic stock install, to very custom apps, to the Java app that hasn't been updated in 5 years because developers nowhere to be found. And so we have all those bits of information, bits of things going on. What that does is present us with lots of opportunities, we'll say, right? Opportunities to learn and to figure out things, right? A lot of troubleshooting, okay? And also, this talk is about going back to, phone's dead. Oh, there we go. Going back to basics. Because we have so many configurations on so many different servers, we can't guarantee we're going to have the latest and greatest monitoring or application software, right? We're not sure we're going to have New Relic, right? Or App Dynamics, or any of those things installed on there, right? Any type of monitoring. So this is a talk about a tool that was pretty much came out, its last really big push was in '93, right? I'm talking about a tool that started in the '90s, ported over from Sun. This is not the latest and greatest, right? But this is a tool that we can use to troubleshoot anything on almost any server, anywhere, okay? That's why I call it a back to basics talk. That's why I find it super useful for the admins that I work with every day so that they know how to use strace in a very effective manner. Because no matter what's on that server, they can understand the very, very base core of what those system calls are doing to troubleshoot what's going on. Okay, so that's kind of why this topic, right? So what is strace? Okay, we'll cover two things: what does strace do, and how to use strace. Okay. First off, very simply, strace can interrupt a process, trapping the system calls and the return codes, and giving it to you on the screen. Okay. Everything that the application is doing and the way it communicates with the kernel, it's letting you know what it's doing, what those system calls are. Okay. So what are system calls? Right. I've already introduced a new term, a new topic. System calls are those functions that the kernel exposes out for you to use from your application. Most applications don't call system calls directly. They call libraries, right? Things that are implemented by glibc or different C libraries to then talk to that hardware directly. Okay. So your system call is that kind of interface between what you're writing in code and what you actually happens with the system, right, with the kernel. Okay. Whoop. There we go. There you go. Yeah. So very basic, right? Jumping right into it. We can use strace first off by doing strace and then the application we want to trace. Very simply, strace and W. We'll do all the examples you see up here, we'll do demos of, so don't worry about what the output is in the next couple of screens. We'll do demos of it, and we'll kind of go through that step by step in the demo section. But what you might get is something like this. All right? You'll get the system calls that you see up here. Okay? Hopefully, if you can't see it up here on the screen, it's a little small, I think. Hopefully, you can see it on your devices or your laptops, things like that. Question?
Anybody object if I turn the lights down in the column a little bit so we can see the screen better? No, that's fine.
That'd be great.
The only problem with that is with the recording.
I'm ugly, it's fine. They don't want to see me anyway.
Yeah.
If we can, I prefer them down. Maybe not. All right. Ooh. All right. I like that. A little better? Yep. And I'm okay with that. Like any good admin, you don't know he's there, he's doing his job well. Oh, wow. Okay. Wait till something screws up in a second. Okay, so that's an example output you might get, right? We can build upon that command and then phone. Thank you, phone. We can build upon that command and add -v to make it a bit more verbose and get all of the gory details. If you can see the screen, notice up here this first line, this exec line. What's happening here is it's combining all of your environment variables into a small structure and not showing them to you. But with a -v, it goes out and gives you all those gory details. Okay. You may hear sometimes that something like cron doesn't run with same environment variables, right? You can probably verify that by stracing it and see what environment variables it does have, what environment variables do get passed to it, right? So kind of really deep and down in all the little gory details, okay? You see all your environment, you see your path up there, your home directory, right? Your logon name, all those little details, okay? We can also trace processes that are already running. This is useful for that Java app that no one wants to restart, and your server has been restarted in 3 years. We see those. Somebody has one of those. Those are fun. So we can trace a process that's already running, right? It's also useful, an example we'll see later on, for tracing like daemons like Apache. And you have a web server, right? Anything that's already running you don't want to kill off, we can do that, okay? Now, in doing this talk a couple times, this example always comes up, right? Big old warning. When you trace a process, strace sends a sig trap or signal to the process. Some processes can detect that and just shut down or act unexpectedly. Usually these are proprietary installers, think Plesk, right? Something they don't want you to kind of reverse engineer. Okay, something that involves a serial number or something like that. This happens all the time with us. When we install Plesk, it doesn't go quite right. We want to figure out what's going on. We'll strace it. And then they'll remember that we can't because it detects that and kills out and says, we're being traced, we're stopped. So literally, your strace process sends a sig trap. And your application is like, whoop, hold on. It's a trap. Hold on. Now, it may continue on and continue to run and give you what you want back, or it may continue to just die, get a sig stop, a sig kill, right? Depends on how the application might be coded. So keep that in mind. If it's something that you really can't have die off, and it's not acting just the right way you want to, maybe look at other options, okay? But again, it's very, very rare that this happens. Again, mostly Plesk, right? It's kind of the big one we've seen all the time. Small applications can give you quite a bit of output, even just small ones like W or password or things like that. So we can save the output to a file, simply like this, strace-o, file, and command, or the PID we want, okay? Ooh, wait. Let's figure out what happened here. Okay. That's good, thank you. All right, not a big deal. There you go. Where is caffeine? Close. Where'd you go, caffeine? Boop. Is it up there anywhere? Where'd you go, caffeine? All right, probably on. Okay. Let me turn off the displays real quick. Well, I know what's going on here, so I'm going to strace it. Let's see here. Turn off mirroring. And there's caffeine. Awesome. Display, arrangement, mirrors. For people who do present, caffeine is a great little tool. Again, it's one of those things that just continues to... whoop, whoop. No. Where'd you go, Firefox? There we go. All right. Caffeine just continues to move your mouse for you, quote unquote. All right. So again, we can direct the output to a file if we want to. Normally it goes to standard error. Just keep that in mind. Not standard out, but standard error. If you try to pipe it and get the first 10 lines or something like that, you just need to redirect standard error to standard out. All right, so next. We can also follow child processes. This is, again, we'll see this a bit more explained in one of our last demos where we strace Apache. Okay? For those who are familiar with Apache, you may know that the root process kind of has the main PID, but it spins off all the child processes that handle all of the connections. We don't want to follow the root process. We want to follow that those children processes more than anything else. Okay? So we can do that as well as you see up here. And these commands are just building on top of each other, right? What we're seeing here is we're doing the -ff to follow the children, -o to put it out to them a file, and then a PID for whatever, maybe the Apache process, maybe it's something else, okay? And the output's going to look something like that. You'll see what you'll get from that command is all the files individually labeled with whatever name you gave it, as well as the PID number, the associated PID number for it. Okay, so useful stuff. We've seen this used multiple times when the scenario is that Apache is seg faulting over and over and over, and we think it's the PHP file somewhere in there. What we can do is do that, strace, follow the children, and attach it to the Apache process. What we'll get is we'll see a process that they all attach and all die off really quickly. And the last line of every single one of those files will be open such and such PHP file, and then sig fault. Okay, so super useful and super helpful when you want to show a customer, look, it's this file. All these processes died from the same file. Did you change anything? No, right? Except that one file, right? I've been on the phone with customers for 45 minutes to an hour. Did you change nothing? No, no. Show them that. Oh, we did change that one thing, but it shouldn't affect it. No, it's part of the framework. So, all right. You can also use strace to not only get the output, but get stats, get a summary of the system calls that were made, any errors, and how much time they spent on each system call. This is useful when, for example, I'm not sure where to start looking at a process. Right? We've already seen here the output can be quite big, and we'll see it again in the demos. So it's helpful to see, okay, where is it spending most of its time? Is it spending most of its time mallocating memory? Is it spending most of its time opening files, checking for other files? Right? We'll see that here. And what you'll see is the output looks something like that. Okay? You'll see here that you get percent time that's spent, and it's percent time in system calls. Okay? From the man page, it's trying to measure that from the time difference between going into the system call and coming out of the system call. Okay? You'll get the number of seconds it's spent. I believe that's wall time, if I remember correctly. And then the number of calls it does, the number of errors. The number of errors are the number of, if I remember correctly here, the number of -1 return codes for an error. Okay? Maybe the file wasn't there, right? Maybe something that's not going to be detrimental, but again, maybe the file wasn't there, maybe you didn't have permissions. Any of those things would cause an error on something like that, like an open like that right there. Okay. All right, let's see here. Boop. And then lastly here, we have how a process can exit, right? We'll get that at the very end of that strace file. Useful to see if the process did exit out correctly, right? Useful. Or if it was killed by a signal or with a different return code. Okay. Now we can get the return code from a bash, a variable just as easily, but we can save this and look at it later on. Okay. All right. So that's kind of a quick rundown of some of the flags I find useful and how to use strace. Okay. Our next thing here is going to be system calls. Okay. This slide came up a little earlier, right? I wanted to make sure I introduce a topic or a term and define that very easily on, very early on. And the same one here, right? A system call is simply that. It's a function provided by the kernel that the application uses to access, make hardware calls, right? To write a file, to get memory pointers, things like that, okay? Now, there are about 441 different system calls. I'll show you how I got that number later on. Some of them are synonyms for others. So not quite that many, but there are quite a number of them. We'll go over a few of them today that I find useful, kind of the first ones I want you all to know to kind of really, that most programs are doing, right? Opening a file, reading a file, checking the stats of a file. We'll look at those very briefly. And also, this is one of those sections where I want to talk about finding out more information and learning a bit more, okay? The man pages, usually we hit man and then a command. We get a man page up, right? Now, which section of the man page we get can vary, okay? The man pages are built out into different sections. Section number 2 is for system calls. Now, fine and dandy, but there are some commands, or as you see here, a bash built-in, that have the same name as those system calls. For example, here, read, okay? If you do just man read, you'll get the bash built-in man page. Not what we're looking for when we're trying to figure out what a system call is doing. So simply, man2 read, and then we get, as you see up here, the system call man pages. Okay, and this works for, you can do man2 and then any system call and get that information back. Okay, keep in mind some may bring up the system call page first, some may bring up another one first, right? Stat's a great example of that. You run man stat, you're going to get the man page for it. You're not going to get the system call page for it. Okay, and we'll see that later on as well. Let's see here. I really regret throwing a 30-second timeout on my phone now. All right, a note on system calls. The good thing about system calls is that they all have a similar structure. Okay, as we see up here, okay, you have the system call. If I can do this real quick here. You have a system call, for example, read. Then you have any arguments, right, that you might have for that system call, and then a return code. Okay? And the beauty is that all of these system calls have the same structure. They'll have the command, any arguments, and the return value. Okay? And from the man pages, you can look at what the return value should be, what it means, right, and what those structures are that you are doing inside those system calls. Okay? All right. So let's cover a few of them that I find useful, especially when someone's just learning about system strace. Kind of the ones you're going to see almost every single program doing. So let's start with this. There we go. Opening a file. Right, opening or possibly creating a file. Most applications are going to want to open a file, create a file, things like that. What you'll get up there is you'll give it a path name for it. You'll see any flags you want to use with it, to read only, open, append, any of those things, right? And what you say, you give a path name, and open returns a file descriptor, right? A file descriptor is simply just a small number that the program will use to reference that file later on, okay? And what can you reference that file would exactly be the read system call. Notice here, what's expecting is a file descriptor, okay? Coming from the return code of that file we just opened, if you will, okay? On success, returns the number of bytes read, okay? If you see that you're requesting to read 800 bytes and you got 400, well, maybe you had an error. Maybe you read to the end of the file, right? So you can look at your system calls and see, hey, am I reading as much as I expect to be reading? Yes, no, why or why not, okay? And then fstat or stat. Again, this is another one of those where if you just run man stat or man stat, you'll get the I believe the application man page. But if you do a man to stat or fstat, you'll get the SysCall man page. There you go. Okay, and this returns the information about a file. This is what the stat command shows you, right? It returns the inode of the file, and in a structure you can begin to read those variables out, right? For example, the inode number, the permissions for it, things like that. Okay. And then lastly, we have the syscalls for mapping memory, right? To map memory to unmap memory, get a pointer back, right? We've seen it where applications just go through and map a ton of memory, and we can show it's doing that by looking at system calls, right? So yeah, again, those are some of the most basic ones, or at least the most introductory ones, right? The ones you're going to first see when you start looking at different applications. All right, so enough of me talking. Let's do some demos. This will be fun. You get a chance to see me type horribly. Okay, real quick here. So on the slides, if you don't see a quick video up here, just refresh your page. It comes up sometimes on the second time. I have these videos up here as part of the idea that you take these slides later on, and whatever demos I'm doing on the screen, you'll see up here later on, right? Obviously, the demos aren't being recorded, so I try to provide these for you all as a kind of base to what I did up here on the screen, because usually that's hard to read, and we'll go ahead and look at, for example, that's not what I want at all. There we go. What's that? Anybody got some? No, that, my friend, is the 50-year. I do not have that. $36,000 bottle. There was 2 in the U.S. 3 years ago, and there's one that came to the U.S. or Canada last year. So they're very, very rare. That one in San Antonio, with kind of just small little plug for San Antonio. That's after the presentation. All right, real quick, I'll show you what the demo looks like here, and then we'll switch to the terminal so that kind of we can get a better view of it, okay? When you hit play here, what you'll see here is just, again, it's quite small, and we'll do it better, but again, an idea of what's going on here. It's a thing called ASCII Cinema. You can copy and paste anything here, right? Play it back, kind of step it through, all fun stuff as part of kind of take it back and use it later on. But for here on the screen. All right. So boom, strace dash w, right, or w, right? Again, the first example here, how to use strace. Very simply, we can run a program and run strace around that. Trace program from the get-go, and we see here, right? Notice what we see here, also up here is this first line, this exec line. Where'd it go? I probably missed it already. All right, let's do this. This is easier. strace w, 2, 1. There we go. Again, everything goes to standard error, switch to standard out. Again, first part of almost any strace you're going to do is this first exec line. Okay. Notice that we saw earlier that if we just do with strace and w, we get very small condensed output. Okay. All right. Yeah. Yeah? All right. Cool. Thank you all. Appreciate that. Okay. So what you see here, right, is this first line. Very, very simple, condensed, right? So building upon that, as we saw in our usage, I'm just going to add dash v to that. Again, real quick, in case anybody's unfamiliar, what I'm doing in this part right here is not part of strace itself. I'm redirecting standard error to standard out, so I can just grab the first 10 lines of that with the head command. Again, not part of strace itself, just a tool I'm using. So, right? So that being said, we see now our first line here a bit more, right? All of our environment variables, everything's expanded out for us. Okay? We kind of want to get the nitty-gritty of it. Okay? If you ever have a program not running quite right, but you think maybe it's not getting a variable or a path or something not exported properly to it, somebody else can help you out. Okay? And again, lastly, we see here our return code. All right, so let's switch back to, make sure I'm going with the slides here. All right, so the next one here, strace dash c and w. I'm not going to run it this time. I'm just going to switch back to the screen here. Strace dash c and then w, right? And when we get this time here is we get the percentage of the time spent on the calls where it's spending all its time, okay? So if we notice here, 245 calls to open, all right? Just jumping back here real quick. Take off the head here. All right, we'll notice that a simple program like W spends quite a bit of time opening, let's see here, quite a few files from proc, okay, just to get some stats for itself. Okay. So it spends a lot of its time there. Sometimes tech comes to me and says, I want to learn how to just get better at programming or get better at X, Y, and Z. Projects I've given in the past is use strace, trace your simple tools, rewrite them in your language of your choice to learn how to use it, right? To re-implement some things. So you should be able to look at this and kind of get an idea of what's going on, what files it's reading, where it's getting stats, things like that. Okay? All right, so again, we see here where it spent all its time. Now, for example, let's say this program I wasn't familiar with, I might start looking at, okay, let me spend some time looking at all the opens, right? Now, I'll show you a demo of that here in just a second here. Make sure I'm on my slides. All right? We can do something like this here, strace-o, password.out. Okay? Right, again, the O, local machine, don't anybody try and cop on that now. Will take a small amount of time to figure that password out. I've learned my lesson before. So when I do a -o, what I get is everything with the standard error now goes to a file. And I can interact with the program as I would normally, like you see here, everything going to standard out that should. Okay? And I can look at my file and say, less password.out, and see my file there. Right? I can look through it, see what's going on. Kind of have some fun with that. Now, let's see here. Are these demos going too fast, too slow? Should I slow them down? Good? All right, got some thumbs up? All right. No one's saying no. Awesome. All right, so here's a fun one. So we had a scenario one time where, let me back up a little bit. As part of my role at Rackspace, one thing I do is teach Red Hat classes. And part of those classes are to have strace enabled for everything. And a question came up, why we need to have, or not strace, I'm sorry, wrong presentation, SE Linux enabled for everything. And part of that, there's an exercise in recovering the root password where we need to relabel all the files. And the question came up, why do we need to relabel? We're just changing a password. And so what we found out is that part of this is going on. Let's say we do a ls dash, I think it's I, etc shadow, right? We have the -i gives me the inode of that file, okay? And when we did a password, let's do a password again. Password. Okay. We saw that the inode of etc shadow changed. So hence, if we're in a recovery mode with no SE Linux enabled, it wouldn't get context. But we wanted to figure out what was going on there. So the first thing we did to troubleshoot that was we did, how you saw earlier, was strace-o, password.out, password file, okay, or password command. We did that, okay. And let's say we looked at all the files there, and we said that's a lot of lines to look through. I don't want to look at that many lines, right? But we knew it had something to do with the file. We knew it had something to do with operation on etc shadow of some way. And so the next thing we can do with strace is to limit the types of system calls that we collect. Okay? I consider this a bit more of an advanced or a next step. That's why I didn't include it in my first part. But I want to include it in demos because I think it's super useful. And it's a way to begin to really dig down and filter out what we need. So let's take the command here, and I'll break it down for you. strace-e trace equals file-o password trace.out and the password command. What I'm telling strace here is to only grab any operations that have to do with a file. Open, close, create, things like that. Okay? And so let's do that. Okay? And then now all of a sudden our area to look through is now 142 lines. Okay? I'm looking at just the output or the file operations. So password trace.out, right? And we see only all the opens, right, when we get. I'll shortcut a little bit here because that demo took forever, or that kind of troubleshooting process took quite a bit of time. But what we found out was that at some point, right, the password command renames a newly created file to etc shadow, therefore the new inode. Okay. Therefore, if you have SC Linux enabled and you need, or it's on a running system, you need to relabel everything there. Okay. So kind of a way we try to troubleshoot our own things, try to figure out what's going on, and balance something like that. Okay. You'd be surprised the number of applications that do just that: open a new file and then copy everything back into place after the fact. So kind of a fun one. Again, that one was just like this. -e trace equals file, and you can do that trace on different families, not just file operations. I can say just the opens or just memory operations. Okay, I can really narrow it down like that. Okay. All right. And then we have another demo here. Again, that video there is just a demo of what I just did, so you get a chance to see it later on as well, in case you want to review it. Again, building out a little bit here. Again, not quite a new demo, but again, the difference here. All we're doing is the -v here to get a bit more output, right? And then, yeah. Well, again, what we see here is a bit more of the information, right? And right here is an example of what you might see as an error. If you look at -c, right? Again, nothing that's going to kill the process, nothing that's fatal maybe, but maybe something that wasn't found the way it should be. Okay. All right. Sorry, say it again? So the question is if I can filter out critical versus non-critical errors, and that's not that I found. Just when you get that -c part, right? Let's see here. Right. Now hold on. strace. -C, W, right? That there's no, it's just returning back wherever it comes back as a -1, right? So not that I found. There might be, but not that I found. So, all right. Come with my caveat, like maybe it's out there. There's a whole lot out there. All right, let's see here. Okay, and then one last demo here. This is a fun one. So strace-ffo, our file, right, and then our PID. You see here a little hint here, HT access and file access. So our scenario, we had a customer who had their Apache document root on an NFS mount. And it had been that way for a long time. Everything had worked just fine. All of a sudden, they brought new developers, and then things started to take a turn for the worse. Actually, let me sync this up here real quick. There we go. Okay. So you basically got new developers, and then, like I said, their performance took a turn for the worse. And we asked them what they changed. Nothing, right? But something had to have changed. So this demo here, I don't have it recorded. It's kind of a fairly long demo, but I wanted to at least walk you through it to see it on the screen at least once. If you have questions later on, come up to me and ask me, or reach out to me on email or whatever, and we can do it again. But this demo here is on this server, I have a Apache server running, and only thing I've changed here for this server is I've lowered the max connections per child just so I can see things, my threads spin up quicker than I want them to, or quicker than they would normally. Okay. All right. And then what they had done is, let's see here, where did it go? One second here. There we go. There it is. Okay. All right, so let's do this real quick. I'm going to bring up here and say, while true, actually, strace. All right, vagrant. See, local boxes. While true, curl. Okay. While true. Okay, fair enough. Okay, so I'm just creating traffic on my server here. Okay, now what I can say here is say systemctl. Yes, I'm running rel 7 or sent 7. Status HTTPD. Right. Because what I care about here is the where'd you go? That right there. I'm getting the PID of the main Apache process in this case here. Okay, and what I'm going to do here is say strace -ff, again, to follow those children, -o, and we'll say /temp Apache, or let's say SCaLE.out, and then I'll get a PID number after that. And then -p there, okay? Did I get that wrong? There we go, that one instead. That's weird. Okay, hold on here. There we go, main PID. That's what I was looking for earlier. Okay. There we go. Okay. So what you see here is that because my max connections is so low, I'm spinning up processes quickly. Okay. And what we'll see here, if I just kill this off real quick, is if I go to temp. Look at all these files here, right? All those are the Apache processes that we're running. Okay, let's look at one of them really quickly here. Okay, do I have it here? Okay. Okay, so the setup here is that if you enable HT access on an Apache server, right, every directory that you have in a path needs to be checked for HT access, okay? And this customer had their, as they called it, their directory structure very organized. What that meant to us, it was a very deep and very wide, right? Just a lot of files, okay? So for an example here, let's do this here real quick, and say curl, smell, all right, I'm not even kidding, it was about this deep. Sorry? Oh, never. So let's go back here and say slash, there, okay? Let me double check something here on my settings. Okay, there, that one's good, okay. Do I have that correct? I think I do. All right, let's see what happens here. Okay, so while true, do that, right? Hello, hello, hello. Awesome. And while it's going on, temp rm-rf scale. All right. And then our strace command here. Okay, so again, I haven't changed Apache settings too much right now. So let's go here real quick. And I'll cut it off just in the interest of time and say we have 255, right? Just picking any of these here. Okay. Now, if you look at that, notice it for here, it looks for HT access for just var-dub. I have it turned on just for that, just so I can find it in here. But you know, it goes through the path of getting the stats, and not a big deal, right? Let's see here. Now, let's turn on, again, closing everything off, resetting everything. Let's turn on HT access here. Okay. And this is going to be in our var-dub HTML directory, right, where all of our path is. We're going to come down here and say allow override all, because that's the easiest answer to get working right now. Not the best, but the easiest. Okay. All right, we're going to save that. System CTO, restart, HTTPD, system CTO. How many times I did that before? It says CTO instead. Oh, all the time, right? Tab complete, I'm like, oh, dang it. All right, system CTO, restart, HTTPD. Okay. That worked. Thank you. Timing, right? All right, so let's go back here and do this again. All right, system CTO, status, HTTP service, and let's get our main PID again. All right, and then we're going back to our strace here of that. Okay. Again, as we saw before, attach, attach, attach. Great. Now, if this was seg faulting, you'd see attach, detach, attach, detach, and you'd find your error. But that's good here. Now, let's take a look at any of these here. Less. Let's see your scale. That. Nope. Oh, sorry. Scale it out. All right, let's grab one of these. Thank you. Now, notice here is what I'm talking about here. What was happening was that check that directory, that directory, that directory, right? Right here, right here, right here. And all of a sudden, you're adding in higher number of calls to an NFS system that you don't really need, right? Why did they do that? Well, the developer said they need to change some Apache settings, right? And there wasn't much, but they need, because that one change, you add all this overhead. But they wouldn't believe us until we showed them something like this, right? How could such a small change have such a big impact? Okay? So you have that many more hits to an NFS directory, that many more calls on it, your performance is going to suffer quite a bit. Okay? So.
And they wouldn't see it on their laptop.
Yeah, they wouldn't see it, right? Because it's just them. But now throw on their 20 rub heads, right? All hitting that same NFS directory. So again, this is one of my favorite examples of how we can use strace to show what's actually going on and where the impact is. Okay. So with that, almost going to a close here. Continued learning, my last section here. Like I said, there's no way that I can show you everything. But what I like to do is leave you with some extra bit of I hate the word homework, but opportunities to learn if you so choose to do. Up there on GitHub, you can find some code examples, very, very simple C code examples that will help you illustrate when I do a simple open of a file or read of a file. What system calls does that translate to, right? What do those translate to? So I'm going to give you a real quick example of that on the system here itself. And let's see here. If I close this here, shut that off because we don't need that anymore. And let's see here, cd. strace code examples. Okay, what you'll see here is some very, very simple C code. All right, hello world. As with anybody first programming out, hello world, right? But what we can do is compile that, GCC, let's see here, hello world C, okay, good. And let's run a.out, again, the basic standard, just a normal file gives out there, hello world. But what does that turn into in system calls, right? We mentioned earlier that applications don't, bless you to all of y'all, force of habit, strace here and say hello, or sorry, a.out, right? What does those simple library calls turn out to be in strace? There we go, right? We're going to see here all the things it's doing just for a very simple hello world, okay? Now you can build upon these examples and say, what if I read a file? What if I malloc memory, right? And see what type of system calls you get back from that. So you begin to see, as you tie those together, and you look at bigger applications, you see what they're doing, right? And you kind of get an idea of what's happening in there, okay? So again, just a real quick, small code examples. If we look at the open file, goes through and tries to read a file, okay? And then again, following through with this, it's real quick here, GCC, open file, C, that's fine, old code. But if we do a.out file, there we go, right? But if we do this now and say if things we learned earlier today, strace -o myfile.out, that. Okay. Again, now we get to see what those small opens and reads look like when it comes to what's actually happening at the system level. Okay? And that's the way that y'all can go and learn a bit more about that, right? Small code, find other code online, and do the same thing. Okay? It just helps you to visualize what's actually going on code-wise to what's actually happening on the system itself. So, all right, let's see here. All right. So, towards the end, I would like to kind of jump back to the beginning here. Let's do this here on my phone. Because, like any good talk, right? Show you what I'm going to talk about it, and then tell you what I told you. So, kind of in summary here, we talked about why this topic, or why I find it super important for techs to understand, and why I wanted to share it. Hopefully, you all found it important and found it useful, or can find it useful walking out of here. Talked about what is strace, talked about how to use it, right? And then we talked a little bit more about system calls and what those mean. Okay, we did some demos up there. We did some horrible typing, or at least I did. Things worked for the most part, which was kind of cool. It's very rare that happens. And then we talked lastly about continued learning, right? How can you all take this from this presentation out into your next troubleshooting adventure, we'll say. Okay. So with that, again, because I'm not used to having an introduction, which was kind of very nice. Thank you very much. Real quick, contact information. Except by the end, my name is Alex Juarez. I'm a principal engineer at Rackspace Hosting. My role there is a lot of training and mentoring of our front-end support and techs. So doing things like this for them daily, kind of on a one-on-one, or doing things on a weekly basis with brown bags, kind of what I do there at Rackspace. Okay, you can find me online. And then my friend Jill was nice enough to write me a bio, which was right up there. So again, I'm not used to having this up there. So real quick, that's all. And then lastly, Q&A. Oh, we talk about whiskey. Let me top up here real quick so I can see y'all if you have questions. Questions? Correct. Yep. Yeah. So question was, strace included in most distributions? Yes. Strace was ported over from Sun in 91, and then kind of merged together for a 2.5 version in 93. So it's been around for a long time, and in all systems I've seen, it's on there. Yeah. Question right there first, and come back here. Question is, how can you strace a cron job? For me, so it wouldn't be the cron job itself that I'm stracing. I would be stracing well, either script I want to run, or strace out the daemon for it and follow its children that spins up. So that's how I attempt to do it, yeah. So, but usually it's going to be the script that I'm doing itself and seeing its environment variables that it's having. So, okay, question?
How do you trace something like Java?
Say again? Sorry.
I wanted to S-trace something like Java, but it's called Unibasic by Dynamic Concepts. So this is a language that kind of stores its source as a P code, sort of like a Pascal-like P code.
Yeah.
And I'd like myself and the developers really are trying to figure out what in God's creation this thing does half the time. And so how would strace be an appropriate tool for that? When I said Java, you kind of laughed, and I understand when you look at the Java JVM argument list.
Yeah, so the question is, could I use it strace to trace something like Java or kind of reverse engineer some code, right? And it really depends on how it's implemented. So like I said, something with an installer like Plesk that would trigger for it might just kill out. And really, it's not necessarily to reverse engineer the code itself, but to see what's happening on the system. Maybe what files you're trying to access, what memory you're trying to malloc, right? So it's not necessarily to reverse engineer that code, but again, more to figure out what ultimately it's doing on the system. Is there a question? Yeah, so if it's using incurses would show that. To be honest with you, I'm not sure. I haven't come across that in my experience, at least when I've troubleshoot stuff in the past. Usually when we're troubleshooting is going to be, for example, what's it called? Coyote, right? So it's web backend or something like that we're trying to troubleshoot. We might look at that a little more. But I haven't seen it use incurses or kind of in that experience before. So, yeah. Question? Okay.
You work with dtrace at all?
The question if I work with dtrace. I do not work with dtrace much. I know it's out there, just I haven't used in my day-to-day. So. Any other questions? Questions in the back? Okay, that's a great question. So the question is, I'm tracing a process and I see file descriptors are already out there. How do I know what they are? I'm glad that question came up. This is fun. If you look at the PID that you already have, go to proc, let's say maybe, let's see here, cd proc, right? All the directories in there are those PIDs, right? So within that, and actually this is a talk I submitted, didn't get accepted, so talk to SCaLE about that. If I go into any of those directories, those PIDs, if you will, let's do one because we all are pretty sure what that is, right? And I go in there and look at the directory FD, or file descriptors. It will give me the file descriptor to the file, okay? So that's where you can tie those together, okay? Any other questions? You're very welcome. All right, any more questions? No? Cool. Thank you.
it's live, unless you want me to leave it off for now. But okay.
You guys hear me in the back? Yeah. Thanks. Okay, so this is actually a talk that I gave internally at Adobe last fall, and it was really successful. I wanted to present it to a wider audience, get more feedback, and see how we might improve this tool. Like she said, my name is Krista Edwards. That is actually my title at Adobe, Salt Master. I do all the salt things for Adobe, which is really fun. And this is about incorporating security and compliance into SaltStack for our security initiatives and compliance standards. So first of all, I want to talk about why did we do this? Why am I doing this? Why did we create this tool? I like pain. Primarily, well, I should give credit to my wife. She inspired me to do this. She works in InfoSec and I work in operations, not at Adobe. We don't both work at the same company, but after work we'll talk about our frustrations. You know, she's trying to come up with the security guidelines to give to the operations people, and they always say, you guys probably know how it is, you know, you're not my boss. Why are you telling me what to run on my box and how to set up my servers and how to do all this stuff? And I'm on the ops side, and I have the same frustration from the other end. So we were talking one day, and she said, you know, you really should take some time, go talk with the security people, see what their initiatives are, talk to them about your initiatives, see how you guys can collaborate, see how you can make each other's lives easier, right? So I went and had lunch with some of the security people, and we talked, and I got a good idea for what they were trying to accomplish and how it aligned with what I was trying to accomplish, or also in some cases how it didn't align with what I was trying to accomplish. And we started to have some meetings and discuss how we can make each other's lives easier. So we started, well, it kind of went like, they had bought some tool and it was supposed to just solve all our problems. You guys know how that is, right? And here, just run this tool, like everything will be great. But from the operations side, I don't have any insight into the tool. I don't know what it's doing. I don't know where it's sending information. I don't have any insight into the results. What we had was they would run something, it would send it back to them, and then they would analyze it, make some report. Then we have the whole ticket as a service, right? They'd make me a JIRA ticket, and then I'd do, and it was just a lot of this around and around, and it was really inefficient, and I was frustrated with it, and I think they were a little frustrated with it. So I started asking them about, what are your requirements? What do you really need to do with this? And what are you getting with your current tool? And one day I thought, you know, I think I could probably just achieve the same thing by leveraging SaltStack as this execution framework, and then essentially send these compliance audits to my systems and have them report back. So from my perspective, I wanted to do this so that I could gain greater insight into the compliance level of my systems. I don't really care so much about the security guys, like they do important stuff, but they're my machines, they're my babies, I'm in charge, my neck's on the line if they break, right? I want to know if they're secure. Whether they know or not is not terribly important to me. So I wanted to move the insight from them to me. I wanted to have more control over what my compliance level was and have better visibility into that than just having them tell me, oh, go patch this, or go, you know, here's another ticket, here's another ticket. So we went from this, just run this tool, and then, you know, security, right? This is what we're using, and I wanted something that wasn't so much of a black box, that worked a little bit better for me, and wasn't just magic, right? So I decided, all right, how am I going to do this? How should I approach this? So I wanted to leverage our existing tools and existing frameworks and not take new tools and new frameworks and add on. This was also about the same time where well, I'm sure you guys are aware, Adobe's a big company. We have lots of different departments. And I was getting kind of instruction from a bunch of different departments. Hey, run this agent on your systems, and run this agent, and run this, security wanted something, and monitoring wanted something, and this other group wanted something. And it was just felt like we were just going to pile more and more agents onto my machine to watch this and watch that and watch some. Like, no, that's way too much. I don't want to have, because then I gotta monitor this agent, and I gotta monitor that agent, and then NOC has to call me to restart this one, and then restart. Of course, they're not calling InfoSec to restart the security agent, they're calling me, right? And when it's a pain point for me, I want to do something else about it. So I thought, why don't we try to consolidate these down? Why don't we take these multiple agents and tie them all into the SaltStack agent? SaltStack has an agent that runs on a machine. It has a scheduler. It has custom modules. So we can just say, all right, Salt, run this. Salt, run that. Salt, audit this. Salt, monitor that. Let's compile them down, or let's consolidate them down into one and leverage that instead of just loading more and more modules onto our, or monitors onto our machine. So I wanted to, based on my talks with InfoSec, I wanted to let operations do the driving, but let security navigate. So have them tell us what the requirements are, and then let us do them, not just keep it all on their side, and then they'll just create tickets for us. Again, like I said, I wanted to have better insight into the compliance level of my machines based on their navigation or based on their requirements. So this was kind of the early. This is one thing that I really wanted to leverage, and I really wanted to have, again, insights by both teams and not just from one team. I wanted to get rid of the black box and the magic. So the next requirement, of course, comply with all the things. We had this meme pasted up on the walls. This last fall, we had this big push for some compliance standards. We wanted to achieve, this standard and so on. And so everybody was heads down, security for a number of months. And of course, I have to have some memes in here, or right, it's not gonna. Anyway, so I came up with a project. I kind of put it together in my head. I don't know if you guys have the same thing. I have a lazy boy that I call my thinking chair. And I kick back in it, and I think, and then I usually fall asleep. But it's still percolating in there while I'm sleeping, right? And then I wake up and I'm like, aha, I've got it, right? So I came up with some ideas in my head, and I thought, we should do this. And I had to come up with a name for it. I've been accused in the past of coming up with boring project names. So I came up with Project Argus. If you guys remember this old mythology, maybe that's another dumb project name, but I like it, so deal with it.
Does it use JSON?
Yes. Never mind. You're the worst, Corey. So this project is broken up into 3 different pieces. Based on the requirements from the security team, we needed to have a baseline set of security requirements. We also needed to do file integrity monitoring and watch for bad checksums of files and watch for changes in binaries and that kind of thing. And then we also wanted to add additional insights so we could look for, like, what open ports are on a system bound to some binary. Like, is somebody running some rogue thing that's sending stuff to Russia or whatever? I don't know, right? So we broke it up into 3 pieces. The first piece is the CIS benchmarks. Is anybody familiar with CIS? Centers for Internet Security. Is anybody affiliated with CIS? Before I badmouth them a little bit?
Have to comply with it. Does that count?
You have to comply with it, but you didn't write it.
Please, badmouth.
Okay. I like CIS in that they define a list of checks and benchmarks. You should comply with these things. What I don't like is I think they should hire a technical editor and have even a little bit of standardization between their documents. Like in the CentOS 6 benchmark, rule 2.1 is this check, but in the CentOS 7 benchmark, rule 2.1 is a different check. And the Debian benchmark is a different check number. And for a standard, they don't understand standards. Like, it drives me crazy. Maybe it's a little the OCD, but yes. So if anybody knows someone at CIS or something, I don't know, hit them, Corey says, or tell them to hire Larry or some technical editor or something and fix it. Anyhow, so this is the first piece, and I'll talk a little bit more about this in a minute. And then we have the second piece is the file integrity monitoring. Like I said, watching for changes in binaries. We want to gather checksums like SHA-256 or an MD5 or something of all the binaries on our systems. When a CVE is released, they usually say, here's a known bad checksum from a binary. Be able to look for this, be able to query for that, and be able to query our entire infrastructure for known bad checksums was another thing we wanted to do. And then the third piece, we decided to go with OS Query. Is anybody familiar with that? It comes from Facebook, right? It kind of allows you to query your server like it's an SQL database. So you can run these select statements like select open ports, comma, processes where port equals and put together these query statements that allow you to gather insight into running agents and SUID binaries and open ports and all kinds of stuff. It's a really, really cool tool. And there is a SALT module for OS Query. So we can, with SALT, we can send out and query all of our systems at once and then bring the data back, just like we have this large distributed database system, and then do comparisons. And we, at Adobe, we send most of our data into Splunk, and then we can create reports and all kinds of stuff. But again, this is the third piece. Now, OS Query can run as a daemon, but we decided not to run it as a daemon. Because again, like I mentioned, I don't want more and more daemons on my system. I want to consolidate them down. I have a SALT agent, and the SALT agent does these queries for me. So you can just send a query right into the OS Query binary and get the results back without running it as a daemon. So we're essentially using the SALT agent as the daemon to pass the query over and then get the results back. Now, so to go back to the first component, the CIS execution module, when I first gave this talk back in August, I hadn't quite open sourced it yet, but it is available on my GitHub now. Be warned, it only currently supports Cent 6 and Cent 7, but I have a new roadmap defined where I want to make it a lot more modular, and I'll talk a little bit more about this at the end of the roadmap, to support Debian and pretty much anything else, any kind of test suite that people want, and even make it a little bit more flexible so it doesn't require SaltStack. I think SaltStack gives us a lot of benefits, but make it supportable by Puppet or Chef or whatever. So I've got some ideas for that, and again, talk about that in a little bit here. So let me do a quick demo of the CIS module that I wrote, and hopefully the demo gods will smile on me and actually work. Oh, if I can get my console to show. Okay. Is that big enough? Can you guys see that all right? Two more from the front row. So the CIS module, I wanted to it's a huge list of these security benchmarks. You should have these mount points. You should have, no exec on this. You should have these security settings and so on and so on. It's probably 130 different checks. And so I wrote them all into a Salt execution module, and I made it so that I could run an individual check, I could run a group of checks, or I could run the entire suite of checks with one command. So I'll do Salt, and I'll target a machine here, and say CIS audit 1.1. So audit 1.1 corresponds with the CIS document, chapter 1, unit 1. Now, if you can even see the results there, but I passed a couple, I failed some. I can run it with details. So let me run the whole suite here. And to black. It was on black, and I didn't know if that was very visible, but I will try. Is that better? Okay. So running the entire suite of tests only took about that long. That was 10 seconds. It's not that bad. I was really concerned about the performance. I didn't want to bog down these machines. So on this test VM I have, based on the CIS benchmarks, I've failed 57 of the tests and I've passed 55 of them. Not great, but this is kind of just a default CentOS install. It doesn't have some of these things applied to it. Now, these results are useful, but I need more insight into this. So I can also run it with details equals true, and it will tell me which tests I passed and which tests I failed, and the name of those tests, and what chapters and sections they correspond with. Now, it's wrapping here because of the resolution, but it says I failed. All right, create separate partition for temp. This is a scored item in the benchmark. I failed that one. So some of these partition things, by default, well, yeah, the default install doesn't set some of these settings. Remove the telnet client. That's one of the benchmarks, which I've argued back and forth with the security guys. The telnet client is not a security problem. I use it to test port connections and all, but it's unencrypted. Well, I understand removing the telnet server, but not the telnet client. Anyway, that's another thing. Right, they've already just used netcat, which can also be unencrypted. So anyhow, so those I failed, and these I've passed. So some of these, honestly, I think are dumb. Like, remove the talk server. What the hell is the talk server? What's charging dgram? I don't even know, but it's in the benchmark. So anyway, those are easy wins. Disable all these. So you see the test name and the test number. If I wanted to rerun test 2.1.15, I could run just that test by doing audit _2_115. And so I can run individual tests, I can run groupings of tests, and I can run the whole suite. But this gives me a good, quick, like I said, about 10 seconds insight into the compliance level of my box. Now, I just ran this on one machine, but because of the way that Salt is designed, it offloads everything to the minion. So I'm not bogging down a central box. I'm executing the audit on each minion and then just reporting it back. So I could run this on 10 systems, 1,000 systems, 100 systems, and it would work fine. But what I really like about this is this gives me, as the operations guy, the insight into what the requirements are and where I stand on those requirements. And then what we additionally did to this was we created, everybody's familiar with salt states, like puppet manifests or, chef recipes or whatever, where you set the configuration down. We created a corresponding set of states that match up to each of these tests. So if I failed on 9.2.1, I could apply the salt state 9.2.1, and it changes that setting, and now I'm compliant. So I have a suite of states that go along with the the compliance checks, so I can easily just patch them, rerun the test. All right, I'm passed, good, great. And then I go on and I can do these one at a time if I want. I can apply a group of them. And then I can easily and quickly patch my systems and then send this report back to InfoSec and say, look, now I'm only failing 3 of these, and I will argue on why that's okay. Yes? Right.
Now that state is managing that file, but say I have other configurations or other things I want to also manage that file, like I have an IPA, pre-IPA plan.
Right.
How do you, so in other words, if your SSH config, for example, or your PM config, so those solely controlled by those states now, for file that management?
Yeah, I mean, a little bit. We try to, so each of our product teams has their own Salt installation. And so we try to work with them to update their existing states to inject these fixes. So we don't have, they have a high state that does 90% of it and then another state that does, and then they're walking all over each other. So yeah, there's a little bit of difficulty there. But oh, yeah. You're doing it wrong. Oh. Okay. Yes.
What about selectively disabling certain sections of the CIS benchmark? For example, let's say that we really need charge-in in our environment.
Right.
And I've negotiated with our auditors, the point we clarify, we accept the risk, whatever it takes there. Can we whitelist that so it doesn't spit out a bunch of failures every time we run the CIS monitor? Yeah, exactly. Sort of a whitelist, blacklist.
Right. So that is something that I wanted to add in the next iteration. This was strictly just kind of a proof of concept. So I wanted to not say, here's the list for everybody, this is the list you have to use.
Right.
You can define your own lists, or you can define your own custom modules and your own custom checks. That's what I want to do in the next builds. Because, yeah, I don't want to have to fail every time I'm running Apache, which is running on my web servers, because duh, right? Let's see. So, that's another thing that really bugs me with the CIS benchmark standard. There's a whole chapter, which I call the dumbness chapter. It says, don't run Apache, don't run Squid, don't run, well, it's a web server. Of course I'm going to, and if it's not a web server, I'm not running Apache. My security team insists that, well, people are dumb and they'll run Apache on not an Apache web server. Maybe it's just me, but I don't want to fail my web server audit every time because I'm running Apache. There's a whole section of turn off like every service.
We switched over to Nginx. We're stupid.
Yeah, and I think this only checks for Apache, doesn't check for Nginx or Lite or whatever. So, yeah. So custom checks, custom things. That's in the next iteration. So, I think the wins that we get with these CIS benchmark checks is it's really fast. The checks. This was on a VM, and it took about 10 seconds. So if I'm running it on a bare metal box, it's probably going to be even faster. It's very flexible. I can add and I can remove checks. And in the next iterations, I want to add more and make it more flexible. And it's collaborative. The checks is just a Python module for Salt. So InfoSec can add checks to it, or I can add checks. It's all just in a Git repo, and people can collaborate and add and remove checks and make it more customizable and so on.
We retain a bunch of mouth breathers as our auditors. What about reporting? If you show them something in a terminal, they freeze up like scared rabbits.
They do. So we created some really pretty pictures in Splunk where we can return this data. So anybody familiar with the concept in SaltStack of returners? Instead of just sending the data back to the console, you can say, send this to MySQL or send this to whatever. We've written a Splunk returner, so we can send the data directly back to Splunk. They can parse it, create some pretty dashboard with graphs and whatever, and then the auditors are happy. I don't know if Scott open sourced it yet, but it totally will be. There's no reason not, that we wouldn't. Yeah. You want that too? Okay.
Sorry, 4 days ago, I wrote a really, really, really crappy version of what you just demonstrated. I didn't know your thing existed, and I want to go back and slap myself.
Okay.
Instead of reading about Docker. Sorry.
Oh, all right. So these, I think, are some of the wins. There's been a couple of questions about potential flaws here or there, or how do we address this? And again, in the next iteration, I want to improve on all those and address those. And because I want to open source this, I want feedback and I want contributors. And if you have ideas on how to address the difficulty with competing states or something, let's do that. If we want to, create prettier output or something, let's do that. Let's work together on it. Now the next piece is the file integrity monitoring execution module. Also open sourced in my personal GitHub. Now, what this does, of course, is it's actually broken up into 4 steps. There's an execution module, but then there's also a Salt orchestration runner that runs all 4 steps and brings the data together. So first of all, it gathers the data, so it gathers the checksums of all the binaries. The execution module is flexible, so you can tell it what type of checksum you want to gather, whether it's a 512 or SHA-256 or an MD5 or whatever. You can give it a list of targets. If the target is a directory, it'll walk the directory. If it's just a binary, it'll just do that binary. And you can configure where does it store the results. One thing that we found early on with this is that gathering all this data for all the binaries across all the systems was a lot of data. So early on we thought, okay, we're already running 2.5 terabytes a day through our Splunk. We didn't want to make it worse. So what we did was, let's gather these every day. So it will gather all the checksums and save them on the system. That creates our day 1 benchmark. Then the next day it runs it again, creates a second file, then it diffs the files and only reports to Splunk what the changes were. So if this has changed or this was removed or whatever, that's the only thing that's going to Splunk. So instead of thousands of lines, it's a dozen lines maybe if we applied a patch that day, right? So in this iteration, it will gather all the checksums, save them on the machine, and then date them, and then diff them, and so on. And then I put together the orchestration runner that goes out and says, all right, everybody do your checksums, save them. And then the next step is the master will go out and say, all right, everybody give me your diffs, and they're all collected back centrally to the master. And this was before we wrote the Splunk returner. So we were running a Splunk forwarder on the master, and it would read in that log, and that's how it would get the daily diffs. But now we just want to do the returner directly from the minion. So it does the diff and then sends it directly to Splunk, and we kind of move the master out of it. This, if you can see this is the 4 steps that it does. This is the Salt orchestration runner definition. So it says, all right, everybody do your checksums. All right, then use the CP push module and send them back to the master. All right, then run the FIM diff execution module and then send it. So it's orchestration as code. Do this, then this, then this, then this, and do it on these targets and gather the data and so on. So it's actually kind of simple. There's just the functions inside of the FIM module, and then it runs those functions in a certain order to gather that data and to send it back. Yes?
Did you run this on a cron on a daily basis?
We run this through the Salt scheduler, but yeah, on a daily basis. Yeah. And because they're all coming back to the master, again, well, that's something we want to improve on and send them directly to Splunk. But we got to use SPLAY with this to say, all right, don't everybody do it all at once, but let's use the Salt scheduler to send it out. I'm going to try and demo this one, but as is, normal with presenting, I was fiddling with it earlier, so it might not work, but I'll give it a try. But for this, I can just do salt run, state.orchestrate. That's not my bug, that's an upstream salt deprecation. Dave, you can fix that. Dave is a salt engineer, if you guys have salt questions. Red Hat has to fix, okay. That's Red Hat's bug. No menu to smash. So I broke this one, but I promise it worked yesterday. That's my fault. Anyhow, you kind of saw what it was doing with this, if you can see this, but it would target out everybody. All right, gather all your checksums, save them, and then we can do a diff, and then we can collect it back, and we can send it. Yes, Corey, again.
Sorry. Typically, how long does it take this module to run on a node that is a typical production node that may have a large number of files, not necessarily a file server, but something?
It really depends on what the targets you define are. Like if you wanted to scan everything on your box, that's going to take a long time. We limited it initially to like just the paths or the directories that are in your path, so most of the binaries. And actually, this is a demo that I can run. I can't run the whole orchestrate thing, but I can run. So I want to run fim.checksum on this list of targets. I can define the targets, and it doesn't really take too long. Now, that's not a huge list of targets, but it's going to walk through all those directories and scan every binary that's in those. But, there you go. By default, it's SHA-256, but it's configurable. You can define whatever checksum you want, and it gathers all of this data. A time, checksum, C time, GID, group, hostname, inode, mode, M time, size, target, type, UID, user. They want, our InfoSec team wanted like everything. So if the ownerships change, we want to know about it. If the M time change, we want to know about it. Yeah. It's actually, it's a combination of two existing salt modules. There's the file.getHash, and I forget the other one, but it's just, hey, salt, go run a checksum on this file, and then it parses it and puts it in this little YAML output and stuff. So that didn't take, is that too long for you, Corey? No. That's acceptable?
Yeah. I've seen overs in the tripwire kill boxes when they run.
Right. So there's that piece. Here's some of the stuff that we put together in Splunk, which I don't know if you can see. This is rare targets. So binaries that we're only seeing a few times across the environment. So we found like 2 instances of AB, or 2 instances of area check. I don't even know what that is. But based on the information we're reporting back to Splunk, the security team can then run these tools and say, why do we have this one binary out on all of our systems that seems to be non-standard? And then they can, because we're gathering the host name that it's on and all that other detail, they can go track down, all right, this host has this one binary, let's talk to that team, let's see why this is on there, let's remove it if we can. We also gather rare permissions. So some of these are 0655. Why is it 0655? That's, or 0510 or whatever. These are rare permissions that we find based after gathering all this information and parsing it and generating the reports. So we can go in and look for weird permissions on files and easily track that and see it. And then again, the last piece, the OS query execution module. This was newly added in SALT 2015.8. I believe the original developer of this module for SALT is Gareth, one of the conference organizers. So awesome for him. I don't think he's in here, but we are loving this at Adobe, and so I need to thank him for building this module. I went to build it, and I've found this a number of times. Corey's probably seen this too. You go to build a module for Salt, you go check really quick. Oh, already done. Oh, already done. Salt, what's the quote? Salt reads my mind in the future,
Yeah.
right?
What's really sad is when you have a question and you Google for it and you find your own name.
Your own blog, right? Yeah. So let me demo quickly the OS query module. Again, OS query allows you to send queries to your system, kind of like a select statement. So I've got some of these in my history here. I'll just go back up. So this is going to query for name, address, port, path, command line, for processes, anything essentially that's bound to a network address that's not localhost. So we want to look for anything that has external facing connections. So we can feed these queries into Salt and run it across all of our boxes, and boom. That was really pretty quick too. So let's see what we have here. A number of these. So SSHD, that's safe enough. The Salt Master, XINetD. So it looks like it's grabbing for IPv4 and IPv6 and all the information about the path and the port and the PID and everything. So we've put together kind of a long list of these queries. We stored them in Salt's pillar system so we can update them real time without having to restart daemons and stuff. And so we have an OS query runner which will query all the queries that we need out of pillar and then run them. We put that into the Salt scheduler and it feeds it into Splunk, and we can generate, why does this one box have an outbound connection on some random port, where it really shouldn't. We've got a couple examples of queries here. So that's the one I just did. This is processes. I didn't write some of these queries. I'm not like a DBA. I don't have to be a DBA to run this, but so this one found the Monet daemon, the MD5 of it, SHA 256, how long it's been running, all that kind of stuff. Salt Minion, Salt Syndic, that one. So, yeah. So the OS query module is open source. It's upstream Salt. It's not something that we made, but it's something we use. And the queries, I don't know that we've published the list of queries we're using. I don't know if that's of interest to people or if that should be part of the project or not, but you can.
What are those examples of reading?
Yeah. So what's coming? What are the next steps here? Like I said, I demoed this at Adobe last fall. It got the attention of the security managers, and then the security director, and then the VP, and then it kept going higher and higher, and I had to demo this to the CISO, which was a little nerve-wracking. And his first issue was, well, we already have this tool that we're using. Why do we need another tool? Why do we need to recreate the wheel? From my opinion, it's, well, we don't have to spend $1 million on this other tool. We can write our own, and we can just hire somebody to do this, right? And we get the results faster. We have better insight. The tool that we have does essentially the CIS benchmarks and the file integrity monitoring, but it can take up to a week for us to get the report, which is totally not useful at all. We get these back in 10 seconds, right? And all the functionality of OS query is just icing on the cake. None of that functionality is in the tool that we currently are replacing with this. So they like that, and they've given us the go-ahead to keep going with it. The one concern, though, is Adobe has two major business units. We have digital marketing and digital media. Digital marketing will be using this. Digital media is still using the old solution. So one of my challenges is to make this flexible enough so it doesn't require SaltStack. I think SaltStack, again, gives us some wins, but it doesn't require SaltStack. It will just require Python. If you can run Python, you can run these audits and get these reports. I want to make it more flexible. Right now, the CIS execution module is about 3,000 lines long. It's got 130 checks in it. It's one Python file. It's too big. It's unwieldy. It's difficult to maintain. I want to break it all apart into individual checks. So you can then just piece together and say, I want this little collection of checks or this collection of checks. It's not an all or nothing thing. I want to add support for Debian and Ubuntu and Arch and whatever. And if contributors want to support OpenSUSE or Slackware or whatever, make it flexible so that it supports multiple distributions. Right now, the current state, again, only supports Cent 6 and Cent 7. Pardon? Salt Syndic? Right, yeah. We're using that. We have a central master and then tiered masters underneath, and we run this, and it currently supports and passes through the syndics and sends the data back up to the top. So that's already in there. Trying to think of some other things, but essentially, we want to make it more standard, more flexible. I want more people to be able to use it. I don't want it to be, although I'm definitely a Salt fanboy, I don't want it to be specifically tied to Salt, although I may add extra bells and whistles in the Salt version. But, so, if you're interested in this project, hit me up on GitHub or whatever, email me or something. I'd like more collaborators, I'd like more insight and more feedback on how we can improve this and make it a shareable open source project that lots of people can leverage. In that regard, we are hiring somebody to help me build this. Adobe is looking for a Python developer, preferably with some SaltStack experience, to help build this out, mature it, make it available, and we're open sourcing it, which is huge. I really like that they've said okay about that at work. You would probably have to move to Utah, so a bunch of you just checked out. But we do have an office in San Jose and San Francisco. You could probably work out of those offices if you're near one of those. Anyway, if you're interested, you can email me. Beyond that, here's my contact info. Here's my GitHub. I've got some old crappy projects on my GitHub. Don't pay attention to those. Just pay attention to the Salt ones. But who doesn't have really old legacy crappy code on their GitHub, right? Like, I was just trying something out and it's on there, but I should probably delete it because it's embarrassing. Anyway, so with that, is there any questions? Yes.
So that everyone can
Speak into the
hear.
mic.
When you were speaking about the file integrity monitoring, it sounded like you were storing the files locally on the machines. Is that actually the case, and doesn't that have some substantial security implications?
So maybe I should clarify, because that came up. We gather checksums of the binaries on the local system, and then the master gathers those results and brings them back to the Salt master. So they're removed from that local box so nobody can tamper with them. If somebody had access to our Salt master, we got bigger problems, right?
Yeah.
So we immediately grab them, bring them back to the master, do the diffs, process the data, and send it to Splunk. So we tried to, yes, that was a concern that we addressed.
Cool, I have one other.
Yes.
This is very interesting. How much of it is highly specific to Salt, and how much of it could be brought into another configuration management system?
Right now, it is fairly Salt specific. But like I said, in the next iterations, I want to make it more generic and more flexible. So if anybody wants to help with that, patches are welcome, right? That's what we say. So, all right, thank you. Yes, we got one over here.
Okay. I have 1.5 questions. First, are you allowed to mention the name of the product that the security department was using?
I can, but how about I tell you after?
Okay.
I
And
don't
so
wanna-
the other is, when you put this on GitHub, then all of a sudden the world knows some of the checks that you're using on your servers. Did security have a problem with that?
We have additional checks that we use internally. The stuff that we've published is based on public standards that anyone has access to. So I suppose it gives some insight into what some of our checks are, but if they're patched, then we should be safe from them. So that has come up as well, but I think we're comfortable with it.
So that was the argument you had given the security people when that came up? Like, this is publicly known anyways, that these checks are standard?
Yeah.
I mean, okay,
Yeah.
thanks.
We have another one over here, I think.
Have you looked into like salt master lists and daemon lists, things for places where you don't actually want to run a salt daemon, where you can just run states locally whenever you run a salt call?
We're not really using any of that at Adobe, so I haven't really looked into how it would work in that situation, but I can see that would be a valid use case that we could explore and see
Right,
what we
right,
can do
right.
with it.
We've looked into a little bit of doing things like that, where if people don't actually want to be connected to the salt master, we can give them all the states and they can run it locally and do their audits locally as well.
Yeah, that's something we could look at into the next iterations. Anybody else? No? Okay. Well, thank you for your time.
Testing, testing. Does this sound okay? Reasonable level? All right, I won't get much more excited than this. Okay, very good. Thank you.
being here.
Great. Thanks. Welcome, everyone. I also want to thank SCaLE for this opportunity. This is a fantastic conference. This is my first time here, and it's really just incredible. And there's an added bonus. So I live in Raleigh, North Carolina, where Red Hat's headquartered, and they're iced in right now. It's one of these like disastrous southern ice storms where the power lines are coming down, gusty winds. So everybody's miserable, and I escaped. I know. Yeah. Unfortunately, next stop is Belgium and then the Czech Republic, where it's going to be even colder. But hey, I escaped the great snow apocalypse in the south just by a few hours this week. So this is really just fantastic to be here. So let's talk about Pulp. Here's the problem that we're trying to solve, is that managing and distributing software is really messy. There's a lot of problems when you try to insert yourself into that process that someone like Debian or Fedora or Red Hat or any number of proprietary vendors do of making repositories of software and other types of content available to their users. One of the problems is that there are just a tremendous number of types. So we have, of course, Debian packages and RPMs that have been the classic staples for the last decade plus of the Linux ecosystem. But then you have things like Puppet packages, and we're talking about how Chef packages maybe their stuff, how Ansible doesn't really package or version their stuff. We have Docker images. We have just other types of system images, ISOs. OpenStack has some image format options. How do you manage and relate all these different types of content to each other? How do you manage them in a sane way without just using 1, 2, or 3 different tools for each different type of content? And what happens when these repositories change? You get new content. Software engineers are always fixing bugs, releasing new features. How do you make decisions about an update for a package came out? Do I put that additively into a repository? Do I replace the previous version and yank that because it had some critical bug and put the new one in? When is it time to say, here's a clean repository, I'm making a break, and version 3.0 is going in this clean brand new version, a clean brand new repository. Similar to how a distribution, we get Fedora 22, and then we break compatibility and get all new versions of things in Fedora 23. How do you draw those lines, and how do you have tools that help you draw those lines? And then locality of content is really a big problem. So Red Hat, for example, is the use case that's on my mind the most for obvious reasons. We distribute a tremendous amount of software via a CDN. So we use Akamai primarily to distribute software to our customers. But then what do those customers do? Do they have access to the internet all the time when they want to have access to this content? Maybe not. We have a lot of really interesting use cases. What about inside a public cloud? Do you want to be pulling content, if you're running in Amazon EC2, do you want to be pulling your content from the public internet all the time? Or can we help you get on-site mirrors of content? And then what about your own content within your infrastructure? Do you have a development team that's producing your own packages and you need some software to help you manage those repositories and deliver those packages to the right parts of your infrastructure? And then with locality comes control of access. And this isn't really like DRM style control necessarily of like, I want to make sure only people who've paid get this, but more along the lines of stability and quality control. To say, we have the brand new bleeding edge bits that just came out of development this afternoon, and that is in a repository that our testing environment has access to. And we can promote that to a different set of repositories that our production environment has access to. And we draw a hard line in between and ensure that these different sets of infrastructure only have access to the software that's been through whatever other process for quality assurance we want to put in place. So with that, let's talk about what is Pulp. Primarily, it's about managing repositories of content. We started, not surprisingly, with RPMs and the Yum family of content. There's a lot of things in there. There's RPMs and Delta RPMs and Source RPMs and various other things. Errata gets into an interesting area. We quickly discovered that the concepts of managing a repository are fairly common across types. So then we looked at Puppet modules and discovered we can have a core set of tools that knows how to take a piece of content and take a repository and associate them with each other. And we can have a lot of pieces of content and make associations with a lot of different repositories and mix and match, move them around, and have a whole REST API and a whole common set of tools and user interface that knows nothing about actual specific types, like what is an RPM, or what is a Puppet module. What do you do with this? The stuff in the middle doesn't have to care. So Pulp supports a lot of different content types. We're going to list a bunch of them soon. But that's one of the primary goals of Pulp, is to be this general framework that you can plug support for many different types of content into. We do have this pull-through cache feature. This is brand new. It's in our 2.8 beta right now. We've not released it yet, but the release will be forthcoming in the next few weeks, hopefully. If you're really interested in that, we're going to talk in detail about that soon. You could help us test it and try it out. That's a very exciting feature that's been missing, especially from the Yum and RPM family for a long time. I've certainly missed it. Pulp's open source, totally open source, GPL. It's on GitHub. You can go see everything's developed in the open, just as you'd expect. You can see the pull requests. You can comment on our pull requests, see how the team reviews each other's code. We do peer review on everything. We always love contributions, even if it's just bug reports or compliments or beers after the conference or anything you might like to share. And Pulp is a Python web application. Now, before you get your hopes up, being a web app does not necessarily mean that it has a beautiful graphical web interface. Pulp does not. Pulp has a REST API and a command line interface. This doesn't rule out the possibility of a beautiful web graphical interface in the future, but right now we have a command line interface that we'll get to know in just a minute. So let's dive into what we do with Pulp. There are two primary things, and then we're going to demo them. So the first is we want to create a repository. Now don't think about this in terms of like running the create repo command line tool that writes some files on disk and now you have a Yum repository of things. This is a more abstract concept of a repository in Pulp. It's really just a record in a database. It's empty. You tell Pulp what type it is so it can get the right plugins plugged into both sides of that repository. Now that you have your repository, you want to get content in. So there are two primary ways of doing this. One is to synchronize with some remote repository like Fedora or like Debian. So you would give this repository a URL and say, I want you to synchronize with that remote source. And it'll grab all that content and pull it in. You do that manually, or you can schedule those kinds of operations. And then uploading is the other primary way of getting content in. So Pulp's REST API allows you to provide a file, tell Pulp what type is this. So you'd say, I have an RPM. Here's this RPM. I'd like you to put it into this repository over here. And Pulp will do that for you. And then the third way is once you've got content in the Pulp, now you can actually move it around to different repositories and make copies. And an important property of Pulp is that copies are cheap. They're really just a record in the database. So if you have 10,000 RPMs in a CentOS repository and you want to, for example, we asked about snapshotting, make a snapshot of what does this repository look like at this point in time, you can copy all 10,000 into another repository, lickety-split. They're just a bunch of association records in the database. And now you have a snapshot point in time. So you can change that original repository however you like. Once you have your repository populated with some content, you're ready to publish it. So this is an important distinction in Pulp conceptually, that the act of changing a repository doesn't necessarily make those changes visible to the clients that are consuming that content. So it's not until you run a publish operation that, for example, Pulp does the equivalent of running create repo and actually writes some files to disk, and now the content you've put into that repository is available to clients over HTTP, for example, although that's not necessarily the only way you can distribute content. You can also, Pulp has the ability to write out content repositories to ISOs. It'll generate ISOs. You can tell it how big they should be. We have a community group that has written another plugin that will actually rsync the contents of a repository to some remote location, which is pretty nice. And for Puppet modules, we actually have a really interesting use case. Rather than making the act of publishing the repository, we had a very strong use case for running Pulp on the same machine as a Puppet master and wanting the act of publishing to actually install the Puppet modules into a local environment, which is really just a directory on your local file system of the Pulp server. So that's what the publish operation there means. It could mean many other things potentially, like distributing your content with BitTorrent or anything else you could think of. So with that, let's do a quick demo, and we'll see how this goes. This demo does, in fact, require the Wi-Fi to work, but the Wi-Fi has been remarkably performant in this conference. We'll see. Is this readable in the back? Oh yeah. Let's get the if we can get the lights down now, that would be the time. Cool. Better? Okay, great. Keep me posted. Okay, now I can't see my keyboard. This will be fun. So Pulp admin here is the command line interface to Pulp, and Pulp admin itself is really just a REST API client. It's laid out hierarchically, which makes it easy to plug in new commands for new content types that you add. So in this case, we run Pulp admin, and the next command we see here is, you can see the cursor, great, RPM. So we want to do an operation on RPM content. And we want to look at a repository, do an operation with a repository, and the action we want is to list. So we've listed, and we see there are no repositories. So let's create one. So here's a command to create. So we have that same RPM category. We want to look in a repo. The action is create. So now I've given it a repository ID for this thing I want to create. I've called it the zoo. And I've given it a feed URL. This is a remote Yum repository. It's live on the internet. You can also go and install packages from the zoo if you choose. It's a great testing repository. So I've created it, and we're done. Success. But we don't have anything yet. We can do this list command again, and we see we have this zoo repository, but there's no content. So as we discussed before, the next step is to do a sync. So we're going to synchronize, and run here is distinct from schedule. So this is the other option. We could, instead of syncing right now, we could schedule this operation to either run once in the future or run repeatedly on some specified interval. And I've told it which repository I want to synchronize. This is going to fly by a little bit, but we're going to scroll back and parse through a little bit of what the real action is. Okay, we're downloading metadata. Now we're getting RPMs. Oh, that was real fast. Got all 32 before we could get a progress update. Published. Okay, we're done. So let's look at what just happened real quick, and then our demo will be over. Okay, we started synchronizing. Pulp downloaded some metadata. This is essentially like a manifest. What's in this remote repository? It chewed on that for a moment and decided which of these things do I already have, which ones are available, make some decisions about what I need to download, then it downloaded them. Looked for some other types of content that it didn't find, not important. That sync task completed. Now by default, Pulp will then kick off a publish operation, which it did here. So it initialized some metadata. It started writing to that metadata. It wrote out all 32 RPMs to those appropriate metadata files. Did some other things, and we're done. So that's the general user experience of Pulp. Oh, and now we can run this list command one more time, and we see that we have some content now. We have 32 RPMs, we have some package groups, we have 4 erratum. This is the way that RPM type distributions express essentially things that bug fixes that are available in a standardized way. So that is the end of the demo. Any questions? Kind of tearing through this kind of fast. Just raise your hand anytime you have a question or yell at me if you don't see me. Let's go back to our presentation and we can get the lights back on if you like. Thank you. Where were we? We're at the demo. Okay, great. Content types. These are the content types that Pulp supports right now. Of course, the RPM family. Docker images are a very important one right now, very popular. Very interesting exercise in keeping up with all the change that's happening there. The change from their V1 API to the V2 API. They've added a lot of really exciting features, but at the same time have changed essentially everything multiple times. Puppet modules are another very important one. Also similar, changed a lot over the years. Several different versions of their API, each one better than the next. Python packages, OS tree. If you're not sure what an OS tree is, it's worth Googling or whatever your favorite search engine is. It's really fascinating technology. It's the foundation of things like Project Atomic, which is another thing that's worth knowing about. Regular files, you can just have a repository of whatever old files you want to stick in there. We have community support for Debian packages. And then we have a community user who's developed a plugin for NPM, but has not shared it with us yet. So we're eagerly awaiting that contribution. Let's talk a little bit about who uses Pulp. Red Hat Engineering was customer number one. All software that Red Hat distributes to our customers and to our users is managed by Pulp. Internally, there's a giant Pulp. Has I don't know how many hundreds or thousands of repositories available, tremendous amount of content. Public clouds. If you've ever in Amazon EC2 started up a Red Hat Enterprise Linux AMI, for example, and then installed software, you have pulled that software from Pulp. So we have Pulp running under a different name called the Red Hat Update Infrastructure, which is basically Pulp with an extra user interface on top of it to do a very specific workflow. Most of the public clouds have this running inside them, and the images that you would instantiate have the information baked into them that will automatically pull from, for example, in Amazon, your region, whatever region you're in. So you get the data faster and, of course, free bandwidth. Catello is the upstream of Red Hat Satellite 6. This is a whole content and like systems lifecycle management project and product that we could talk for hours just about that. That's one option if you're actually looking for some more help in terms of having a graphical interface and a set workflow that uses Pulp to manage content and go through a promotion workflow. Catello and Satellite are a fantastic option. Bless you. And of course we have a thriving community and a growing community that we'd love to add you to as well. So here's a specific use case. This is a real basic one, is just to mirror some content. Python packages are a nice one and a popular one, but it could be any of these contents. So you can synchronize packages directly from the Python package index. You can add and remove, get exactly the packages at exactly the versions that you want, and keep them. I've been using Python for a long time. This is not such a big problem anymore, I think, but years ago it was a huge problem that sometimes versions would disappear from the Python package index. You'd be using some, like Django, whatever, at some version and depend on that version and build all your custom stuff around it. And then when version .next comes out, the old one would disappear. And it's endlessly frustrating. So Pulp is one way to take control of that and have your own well-curated slices of that upstream content, exactly the versions that you need, exactly where you need them. So another use case is this promotion idea that I alluded to earlier of development, testing, production, and essentially we accomplish the promotion by using the copy operation. You start with a repository that either your development team uploads directly to, or maybe your Jenkins or whatever continuous integration or build system you have is automatically uploading content, dumping it into some Pulp repository, and that is attached to maybe just some basic testing framework or testing infrastructure that will run some automated tests and give a thumbs up or a thumbs down. And if the thumb goes up, then that can get copied, all of that, into the next repository that you've set up, which would be some flavor of testing or quality assurance. And maybe some lab has access to that, and you can see where this is going. Finally to production, which could either mean deployment if you're in that business, or production could be, like in more of Red Hat's example, just a CDN or some public space where you're making that software available to the people who are going to use it and deploy it. Yes? Great question. The question is, in the promotion workflow, does it handle dependencies? The answer is sometimes. It depends on the content type. And this is one of the messy parts of dealing with all these different types of content is, what does a version on an RPM mean versus what does a version on a Python package mean? Different things. The algorithm for taking two versions and comparing them is different for all these different types of content. Oh, that's incredible. And the way you express dependencies is also, it's a lot of work to keep up with it all. So right now, RPMs, I think, are the only content type we have that supports dependency resolution. But you absolutely can copy and say, I want you to copy Vim from this repo to that repo and pull all of its dependencies with it, and it will do that. Other questions? That's certainly one option, yeah. So the question is, more detail about the curation process. How do you choose what you want to promote or not, essentially? And perhaps even what do you want to back out? There's a whole search interface. When you do this copy, you can either pick and choose, I want these specific names or these specific versions of things, names and versions. Here's a list, copy only those things. You can remove things in exactly the same way, or you can just go whole hog and copy the whole thing over. The power's all in your hands with the tools. Let's keep moving. Oh, yes, please. Oh, this is a very good question. Is there a way to find the difference between two repositories? This has been a feature that's been requested in the past. We don't have it. We are on the cusp of offering that. So stay tuned. I think shortly after Pulp 3.0 comes out, which I hope will be in the next year or so, maybe 6 months even, that is going to be a possibility. There are some tools for these specific content types that will let you compare. RPM, I happen to know, I think has at least one tool that will help you compare two different repositories, but not yet. But that's a very asked for feature. So Pulp's a distributed application. We're just going to talk through the pieces a little bit so you can see what you can do with Pulp and how you can scale it. So there's the REST API. There is content served via HTTP. Well, as we discussed, it's not the only way you can serve content, but by default, that's what Pulp does with most of these types of content, serve them via HTTP. And then we have these long-running jobs, which kind of throw a wrench in the gears of what you would think of just as a normal, simple web application like this. So here we have these smiling users on the top left, and they're interacting with a web service. And this web service has to be HTTPD. Pulp mostly deploys and is tested with Apache web server, but doesn't necessarily have to be tied to that one. Normally, you have this web service, it talks to a database, it keeps state there, and that's the end of it. But having these long-running jobs really does throw a wrench. So imagine one of these users that we have on the left says, see that repository over there with 10,000 or 100,000 RPMs, I want you to publish that now. That's going to take substantially more time than we can reasonably wait before responding to an HTTP request. So we need some way to deal with that. So we added this extra stuff. We added an AMQP message broker. We support a couple different ones. And this pool of workers. And there's some magic that happens in those workers. Actually, it's not magic. I actually kind of don't like when people refer to software as magic. It's very well defined and very well thought out. But for these purposes, we're going to think of it as a black box because I could do a whole presentation on the guts of the algorithms of how that works in terms of prioritizing and keeping different resources separate from each other. Anyway, I've already said too much. Let's trace real quick through how a request flows and bounces around through here, kind of like pinball style. So this user in the top left we have here, imagine that he wants this publish operations. He's requested, I want to publish this 100,000 RPM repo. That request goes to a process that's handling web requests. That process starts doing web application type things and adds a record to the database. It puts a record in the database about this job, some information about what repository this is, what kind of action you can imagine, what kind of things might go in there. And once that information is there, it'll put a message on a queue on this message broker. And from that point, the web process is done and responds back to that user and says, okay, I queued a job, and here's a unique ID you can use to track that job over time. And at some point in the future, one of these workers will notice that that message on the queue. It'll grab that message off the queue and go access the database and now get to work and actually do that work. The beauty of this is that you can scale these different pieces independently. So if you have a workflow where you have a tremendous number of client machines that are accessing content very frequently, but your content doesn't change very frequently, then maybe you want to scale up your web processes across a lot of infrastructure. Just throw hardware at it. Conversely, if you have a lot of churn, for example, this is one story I enjoy telling. We have one community user. They have hundreds of thousands of RPMs that used to be all in one repository. It was kind of nuts. We talked them into splitting this apart a little bit. But the general use case is this. They had a whole bunch of small web applications, small, slightly reusable web applications. And if you imagine this matrix of web applications and then all these different skins that they put in terms of branding and who knows what else, they end up all these different permutations of packages that need to go together and be built together and be shipped together. And they had these individual, small, very agile teams that worked and made little changes on these things all day, every day. And they would rebuild essentially everything every 10 minutes, all day. So there's just incredible amount of churn. And that was actually part of our inspiration and motivation to make these different components of Pulp very scalable. So they're now able to scale out this worker pool and go either just scale up a tremendous amount of infrastructure and retain a huge pool of workers, or we have this, we can facilitate this cloud burst concept of at midnight every night, everything gets rebuilt and retested, and we only need to spin up some new virtual machines in some public cloud or some private cloud for that period of time when it's cheap. Or whenever it's opportunistic. So we can just add a bunch of workers, do a bunch of work, and then throw them all away. On to the next topic. Pulp's extensible. Getting back to that concept of there's a general way you can approach managing a repository and associating content with it and not caring about the details of what is this piece of content and how does it work, how do I use it. Pulp has this central core with all these tools, and then what you as a plugin author provide is just how does content get in? What's some kind of funnel that you can use to hand content into that core? And then when a user asks a Pulp to publish something, provide a distributor is what we call it. That's the piece that Pulp says, I have all this content. The user asked me to publish it, so here, you know what to do with this. Go. Do that. So how does content come in and how does content go out are the two important concepts that we've separated from the core. So all we need are three primary things. First, a type definition. So again, Pulp is a Python application. We use Mongo engine right now. We're in the process of migrating toward using Postgres instead of Mongo. As you can imagine, that's a big deal. It's taking a lot of time. And we have to be very, very careful. But in any case, you define your type. So for example, Docker blob or Docker manifest. And you tell, in this very simple class, you tell Pulp what makes this unique. For example, with an RPM, anybody recite what makes a unique RPM off the top of your head? Nevra, yes, you get extra stickers at the end. Name, epoch, version, release, and architecture. For a Puppet module, it's just the name and the author and the version. Or author you might call username. They've kind of switched terminology. Anyway, you tell Pulp what makes a unique one, and that's it. Now you provide an importer. This is the thing that implements how do you get content in. How do you interrogate a remote source and figure out what's there, what do I need to grab, actually download it, and then stuff it into Pulp. And then there's a distributor. This is what gets you from, I have all this content in Pulp sitting here, now I want to write it out to disk as a Yum repository. Or now I want to serve it through the Docker V2 API, or one of the several different Puppet APIs to my Puppet clients, for example. And that's it. Those three concepts are how our plugin writers add support for extra types. And those plugins can be versioned separately from Pulp, which has given us some nice flexibility. So any questions about this? I'm just going to move on. Good question. How do you deal with versioning of plain files? You don't. But Pulp doesn't give you that. Pulp manages unique files. It establishes them as being unique based on their checksum and file name. That's correct. You cannot assign a version. It would be an interesting idea. It's something that we've thought about, and if you have some specific ideas, you could maybe brainstorm afterward about it. That's something that there's a general need for that. I would strongly suggest that semantic versioning is the right way to go. If you're not familiar with that, go to semver.org and read and be enlightened. This is largely, in my humble opinion, the right way to do versioning. And it's the way a lot of different types of content do their versioning. Puppet modules, for example. So we could add that, for example. That could be an option in Pulp in the future. The command line interface is also pluggable. This is not very interesting, but suffice to say that hierarchical layout that I demonstrated is the way that you would then, in addition to RPM content, add a new branch of the tree called Docker or Puppet or ISO or whatever other content you want. In terms of integrating with Pulp, this is where the exciting part happens. If you want an out-of-the-box, ready-to-go experience where you've got promotion workflows, you can group different types of content together and promote them and snapshot them, something like Catello is really the way to go. If you are, for example, Red Hat release engineering, you have very specific needs and specific workflows in terms of build infrastructure and test infrastructure and quality assurance and signing infrastructure, being very strict about who gets assigned packages, what's that process of re-injecting them into Pulp, and then what's the gate of releasing. There's embargoes on bug fixes where we're not allowed to talk about, and everybody agrees that we're going to release a bug fix for some security thing at noon on this date or whatever it may be. If you have a lot of process and custom workflows like that, now you want to integrate with Pulp. So we have this REST API is well documented. It's generic, so you can manage all the different types of content. One REST API keeps it very simple, at least. Simple as it can be. I guess I shouldn't oversell that point. It's still a messy business, as I said right up front. We publish events to an AMQP topic exchange. You can, if you want to respond to events, for example, after a publish has succeeded, I want to now kick off a test job with Jenkins to consume, maybe install those packages on a machine and run some tests or whatever. You can do that. We also have HTTP callbacks, a similar way. This is what Catello largely uses at this point to figure out what is Pulp doing and when does it need to respond to something. Okay, this is a very exciting feature. Oh, yes, question. Yep. Yeah, good question. The question is, essentially, is there a Python library that is usable as a REST API client to Pulp? Yes. We call it a bindings library. you can absolutely install the Pulp bindings by themselves and use them to call all of these operations. There is also a Ruby gem, I guess. I don't speak Ruby. But Catello is written in Ruby, so I have to at least tolerate Ruby. I'll say. I don't have anything against Ruby. I just don't really know it. But they have also a library in Ruby that they use to talk to Pulp. I don't know how easy it is to install by itself, but if anybody has an interest or a need to interact with Pulp from Ruby, that would be my first stop, is to check in with Catello. Or just get on the Pulp email list or the IRC channel, and we'll point you in the right direction. Excuse me, KATELLO. And again, Catello is the upstream of Red Hat Satellite 6. Catello brings together, who's familiar with Foreman? Cool. So Catello brings together Foreman and Pulp and this other thing called Candlepin that's really only important to Red Hat, but it's the entitlement management part of Satellite. Catello brings those other three things together into this unified workflow and user experience. Okay, pull through cache. This is the exciting, like, bleeding edge, brand new feature. I used to be a Debian and Ubuntu user for a long time until I started working at Red Hat. I still sometimes use Debian and Ubuntu at home. I enjoy it. I don't like getting into distribution wars or anything like that. There's a lot of really interesting merits on a lot of different sides. So I like keeping my brain in different areas and seeing what are other people doing. What are the best practices over there, and what can we learn? Anyway, one of the things I really liked about my time with Ubuntu and Debian was this thing called apt cacher. That is a simple pull-through cache where if you had a lot of machines sitting in your private network and you wanted them to not each all download an entire copy of the base install of Debian, you could use apt cacher as your proxy, and it would do deduplication, do the right things. Sometimes it worked better than others, but it was there. It was useful. It was very, very useful. That's never existed really for RPM. There have been a couple of attempts. There was an attempt to add RPM support to apt cacher, and that seems like it didn't go very well. So Pulp is on the brink of releasing this feature, first supporting the whole Yum family of content, and then once we get that out and proven and tested, and okay, we've done this sanely because it's a huge, complex feature, then expand that out to all the different, most of the content types we support. There are a couple that, for technical reasons, really are not a good fit for that model. So this is currently available in our 2.8.0 beta. You can go to the Pulp website and find the beta repository and install it and play with it. What it basically does is you still create your repository. Actually, you know what? I'm just going to pull this up and show this real quick. I don't think we don't need to worry about the lights. I'll increase the font size a little bit. Wait, did that work? That did not. Okay. We're going to look at the help text for the RPM repo create command. And we have all these knobs we can turn. Oh, so sorry about the the line wrapping. Okay, the download policy at the top here is how you tell Pulp how you want to make your content available. Immediate does what Pulp has always done. Background will finish your sync very quickly, add all these records to the database, and then start a second job later to go download the files in the background. And in the meantime, you can go ahead and publish your repository. You can start copying things around. All that content is usable through the Pulp API while it's being downloaded in the background. Third option is on demand. Pulp does not download any of the actual files until a client requests them. So we'll look at exactly how that works here. Oh, this did not stay on the slide I was on. Very good question. Am I in approximately the right place? Here we are. Okay. The question is, how does background downloading scale if you want to background download a whole bunch of repositories at once? To some extent, it's up to you to manage that. So for one, you can tell Pulp how much bandwidth it's allowed to use for each download operation. You can also control how many workers are available to Pulp, and it'll only do one job per worker. And that jobs include syncs and publishes and these download operations, all these things. So by limiting the number of workers, that's another way. You can also limit the number of concurrent download operations that happen within any given worker. By default, one worker will do 5 downloads at a time. But you can dial that down to 1 if you like, or dial it back out. So essentially, as a distributed application, we've avoided getting into the essential futile attempts to do smarter things that almost never really work out and cover all the bases of trying to understand what your user really wants to do right now. So here's how this is what that looks like. So starting from the left, we have a yum client that some user typed yum install vim. And yum talks to Pulp and says, Pulp, I want this file. Pulp first looks at its local file system and sees if I have the file locally, great, I'm just going to respond and serve that file. If not, it goes through this new workflow where the first stop is Squid. There's nothing specific about Squid that we've done, so you could use something like Varnish or any number of other similar types of proxies. Squid just happens to be very widely available, so it was a natural choice for us at least. Squid's in reverse proxy mode, and it talks to this streamer thing as a microservice that's also part of Pulp. We've made this Pulp sandwich with Squid in the middle, so all of this conversation happens locally either on one machine or at least on your local network, so we don't have to worry about like man-in-the-middling your SSL connection if you want to do that. So we can still stay secure. And the streamer is responsible for knowing, okay, I know what file you want. I know that file is available in these 8 different repositories, so I'm going to pick one and go access it. And if it's not there, then I'm going to try the next one and go access it and start streaming the bits back. That's why we called it the streamer. So there are actually 4 unique HTTP requests happening here, and bits get streamed all the way back the other direction to the yum client on demand. Does that all make sense? Any questions about that? It's fairly straightforward. There are a lot of edge cases that we needed to cover to deal with this, but it's a very exciting feature I think is going to be very useful to a lot of people. Okay, we have this idea of consumer tracking. We've, in the past, done quite a bit more with support for this concept of consumers, essentially managing what is installed on various machines in your infrastructure. There's a Pulp agent you can run on each of these machines, and Pulp will talk to it and tell it to install and update and whatnot. We're getting out of that business, so I don't want to talk too much about that. Probably as of Pulp 3.0, most of that's going to go away. Certainly the agent is going to go away. What's not going to go away is the ability for Pulp to help you still keep track of what is installed on which machines in your infrastructure, and especially what updates does each of those machines need that is recently available. This is another feature that Catello and Satellite do a really good job of displaying in a graphical way and putting that whole workflow together to identify Heartbleed just happened, and there's actually a really interesting blog post, and there's a presentation. I think the video is not available, but a really good blog post from last summer about IKEA, how they responded to Heartbleed using Red Hat Satellite 6, which is this feature in Pulp under the hood to identify this update's available. These are all the places that need that update. Push the button. It gets the update out to all those places, and you're done. So Pulp can still help you with all that reporting of who needs what. We have some documentation as most projects do. Pulpproject.org/docs is the central place to start, and from there we have links to docs for specific content types, and each one is separated into both user docs and then like integrator docs and developer docs. If you want to write some software that integrates with the REST API, those dev docs would be the ones for you. This slide is more a reminder for me than something for you, but I have these fantastic Pulp stickers up here. They're very nice stickers too. They have this like vinyl finish on top. They look very stylish. I would love to hand some out. I also have a limited number of Red Hat Satellite stickers, and I think 3 or 4 Foreman stickers. So if you like stickers, come up and I'll hook you up with some stickers. And with that, that's really all I have to talk about. So what other questions do we have? Thank you, thank you.
Is there any feature for replicating to say private clouds to get like a whole copy of my Pulp server to another location?
This is a good question. Is there a built-in way to handle replication from one Pulp server to another? The answer is sort of yes, but we have a first cut of that we call the nodes feature. It basically does exactly that. It replicates both repositories with all of their configuration and the content in them from a parent Pulp server to a child Pulp server. Having now put a lot of mileage on that feature and rethought some of what we're trying to accomplish and coming to better understand with much help from our users the performance implications of how that works, we're going to redo it all. So what we're going to do, for example, with Catello, they're going to handle this by doing just a normal sync and just setting up within, say you have like a hub and spoke model. You have your parent Pulp server and then others that are located in offices, or we have customers that put these things like on trains and boats and things that only have connectivity for short periods of time, that you would just set up those remote locations to do a normal sync, the normal way you would from any other upstream content source, and perhaps schedule them or whatever you need. A push model. It's an yeah. I see. So the suggestion is to have a way to actually push all that content down the spokes, that the endpoints don't have access to contact the hub.
I can access the hub, but the systems can't access anything on my network.
Gotcha. Okay. All right. Yeah. Interesting use case. All right.
I have a question.
Yes.
So you mentioned not just syncing other content, but uploading your own content.
Yes.
If you're, say, uploading your own RPMs, does Pulp have a way to create the repo metadata and also sign packages?
Yes. The first and not the second.
Okay.
Pulp absolutely does create the repository metadata. It handles all of that seamlessly for any content type as well. Same for Docker or Puppet. It has the APIs implemented that are required for those other content types. So yeah, you can upload your own content. Pulp does not have any features for helping you sign it. In our experience, most people already have a carefully controlled infrastructure for doing that. But it'd be very interesting to think about a way that we could better support that.
Is there one that's recommended to use with Pulp?
It seems to be a lot of homebrew solutions. As these things go. But this may be the next opportunity for us to help out.
Is there a way to clean up the repositories and control the size of the repository from growing too big?
Oh, very good question. Yes, there are ways to help control the size. There are a few different knobs you can turn. So one example is Pulp does natural deduplication for starters. So if you have the same RPM, for example, or the same Docker image that's coming from several different locations, Pulp will only store one copy of it and recognizes that it's the same one and just stores references in the database to each repository it belongs in. So that's one way that helps. On the sync operation, you can tell Pulp things like, for example, I only want you to keep 2 copies of any particular RPM. So as new versions come out, it'll keep 2 old copies plus the current one and remove other ones. Or you can say, any piece of content that disappears from the upstream repository, I want it to disappear locally also. I have no interest in that anymore. And then beyond that, you can manually delete repositories or remove content yourself. Yes, you can have separate rules for the different types, and in fact, even per repository have separate rules for each repository you have. Yep. Oh, sorry, got the mic over here.
Yeah.
Yep.
Do you have are there public examples of how the promotion, like if you say, hey, these packages failed, whatever, don't promote them, or because I'm actually writing much the same thing, but are there good examples of that you can share or that are in the community?
I don't know of any public examples. Again, that all tends to be very, homebrew Jenkins jobs that orchestrate that kind of workflow. I've not seen, for example, like a Jenkins plugin provided that handles that for you, but that's something that I know a lot of people have done, and maybe if you get on the email list and ask, somebody would be willing to share. I'd certainly like to see it as well.
Is there a question on this side here?
Do you have the mic?
Just to follow up to the other one, first of all, do you still have to remove orphans periodically to remove the old packages? But beyond that, for the Docker repositories, how does that integrate with something like Docker registry? Is there interoperability with that, or is this something that's meant to be completely standalone from that?
Okay, yeah, 2 very good questions. You can certainly kick off this orphan removal process yourself. So there's an orphan removal action where Pulp will go through and identify these are all the content, all the pieces of content that are no longer associated with any repository. Therefore, they're an orphan. So it will then clean them up. You can also run that on a regular basis. Is a very normal thing to do. But you can kick it off manually as well. Now, the Docker question is more interesting, probably. Pulp can be your Docker registry locally. And it can pull content from the upstream Docker registry. So you can both, well, for Docker, there's Docker v1 content, there's Docker v2 content. They're almost completely different animals, even though they kind of kept some of the naming on top similar, and the look and feel is the same. Very, very different content, very different APIs. With v2 content, you can no longer save your images to a file. So with v1, you can say Docker save this repository, and it would spit out a tarball that had all the contents of that. v2 is gone. I'd love to have it back. Help me ask them to put it back and to bring it back, but we don't have it. And so far, we've been losing that argument. So you can't upload v2 content because you can't get your hands on v2 content. But you can synchronize it from any Docker registry, including Docker Hub. And then Pulp has a separate little app called Crane that can be deployed independently. For example, if you Docker pull an image from Red Hat, that is Crane. That's this little read-only web application serving the Docker API, serving those requests. And you can deploy Pulp the same way yourself to be that registry. Correct. Yeah, it implements the pull part of the API. We don't accept a push. You cannot Docker push to Pulp. That just exploded the matrix of both API endpoint, but more permissions of deciding. Pulp has a whole permission and user system I didn't want to get into because it's a boring user permission system, but it's there. And trying to map Docker credentials onto that is a nightmare. So we don't do that. But you can absolutely pull from Pulp, and Docker has no idea it's not a normal Docker registry. Other questions? Going once? Okay, fantastic. Come up and get some stickers if you like. See you around. Thanks.
Test.
All right, thank you all for being here in the sysadmin track. The track is sponsored by Stack IQ, developer of Stacky, an open source bare metal Linux installer. So thank you all for being here. We have here today John Merritt, Director of Managed Service with Stack 8 Technologies, doing a talk on network device configuration, standardization with Trigger, as you can see. So thank you very much for being here.
Thank you. So I'm talking about a subject that's very interesting and important to me. And to lead things off, how would you like to be able to reconfigure 1,000 sites or devices in an hour instead of over 20 days of manual work? That's the type of challenge that I was facing that led to me developing the tooling that I'm presenting here today. So I was working on a migration project for a customer. They were moving between 2 different DM VPN infrastructures, and that engaged us to help them move through that progress. And they provided us with the scripts that prepared to do it, which needed to be customized for individual devices, you needed to validate a bunch of operational state. So say that it took you 10 minutes to make that change on a device, to check and make sure everything was good, and to paste in the substantial volume of new configuration required at a rate that didn't cause iOS to start ignoring half of the commands that you typed. What I did then was I built out a script that validated some show commands, made sure that everything worked well, and made the change. And we were able to automate that process and bring it down to a couple of seconds per device after connection. And I've developed those same techniques through our different practices and projects with customers and in managed service where we're managing environments with large numbers of remote CPE devices. And the stuff I'm going to show you today is really kind of the culmination of the work that we've done on that in terms of going beyond even individual changes to devices and into a structured configuration management approach for network devices. So let's bring this over here. The agenda for the day, first I'll tell you a bit about myself. I'll talk a bit about my feelings on the state of the networking industry. We'll look at the approach that I propose for network device configuration management. And that'll run through the structure of the code that I've created that's now integrated into the Trigger project. It is something that may be a little less accessible for someone with more network background and less Python background, but you'll see in the subsequent section on adapting it to your environment that there are, once that framework is built, extending from it is a lot easier. I'll talk about a few planned improvements that need to be made to the tool, and finally we can take a look at the questions that the audience will hopefully have about the subject. So I myself studied programming when I was in college, and when I entered the workforce I started doing system administration. It's now been distressingly about 20 years that I've been working, and in that time frame I worked more and more on system stuff, automation, and then I got more into networking. And when I changed employers a few years back, I then got into much more managed service and a lot more large-scale network device automation. My responsibilities at Stack 8 where I work, I'm the director of managed service, so I'm responsible for working with our environment to help our customers manage their devices. In some cases, it's professional services engagements. In others, it's where we're providing a completely managed service like a telco would for remote site connectivity. I work in both network and security stuff. We do large managed service environments, and presently we're managing about 2,600 remote CPEs in a variety of different environments. The tooling that I'm presenting today is fairly Cisco focused, at least in the code that I've written. However, the principles behind it are things that would apply to really any platform. And if you're fortunate enough to be using another platform that gives you, a XML interfaces, more advanced methods of retrieving configuration and operational state, the same stuff can be carried into those environments as well. On the state of our industry, it sucks. The networking industry is very much, if you think about where system administration was 10 or 15 years ago, where people were very happy to, manually craft each server and hone each individual element of its configuration, that's really changed a lot. And even in more recent times, DevOps, tight integration between different groups, all this stuff has really changed a lot. And what I've found is that in the network industry, those changes haven't really happened so much and haven't happened in a structured way. There's a lot of manual processes involved. I know that there's a very major telco up in Canada where I work, where they actually build the configuration for devices with their engineering teams using Notepad because the engineering teams don't have access to the network devices. And then field technicians paste those configurations into the devices in the field, but they don't actually know how to work on network devices. And hopefully they report back if errors occur during the device configuration process. Now, hopefully no one here's situation is that bad, but there's certainly a lot of room for improvement. And when I look at the things that people are doing to improve the situation, you have a lot of vendor proprietary tooling. Each of the different vendors has their kind of suite for managing or attempting to manage their devices. And you also have commercial tools that are also quite expensive. And often, suffice to say, I've seen some very expensive implementations of SSH in a for loop. So I feel that there's a lot of room for evolution in this space. And I think that the open switch stuff that we're starting to see from the Open Compute Project, Cumulus Networks, things like that are, I'd like to think, the beginning of a sea of change like the transition from traditional Unix environments to Linux was, and hopefully we'll be able to really improve things in the way that other parts of the IT industry have changed. In the configuration management space, and I imagine this probably applies to most any part of configuration management, not just for network devices, I first am looking to identify specific issues. So we might see, VPN flapping, where specific devices are having a problem and seem to be disconnecting or reconnecting to the network. Doesn't really seem to have an operational impact, but at some point it will. And you want to understand, how big of an issue is this? How common of an issue is this? So I'm identifying either issues in the environment or new projects that need to be delivered for a customer, and then we're generating reports that allow us to sort of examine the information about the systems and see how serious a given problem is to allow us to kind of prioritize specific changes that need to be made, what's more and less important or pressing. Finally, the tooling that I've developed allows us to then make those changes to the devices. And in my environment with large numbers of remote devices in different field sites, I don't have all of my devices operational at any given time. Something's being serviced, there's an outage in a given area. So it's important that the process that we use to make these changes is able to handle a device not being at the current reference, examining the state of the device, and determining what changes need to be made to bring it to the desired configuration. Some changes as well are going to be dependent on operational state. For instance, if you want to make a change to the cellular internet connection on a device, but that's the active internet connection and the primary internet connection isn't present, that's not a change you want to make at that time, especially if the consequence of it is losing the device. To achieve these goals, I've used a number of different approaches. Today I'm speaking about the trigger-based approach that I'm using now, but I've used a bunch of other tools, and probably maybe some of you have as well. So Rancid, which I suspect is familiar to a lot of people in terms of a tool to collect network device configuration and report on changes in it, also has the ability to do custom scripts using SCaLE, its tool for connecting to devices. So I started on that first migration project I spoke about before, writing scripts in TCL and pushing them out using SCaLE. TCL is not the greatest language ever. Two little pet peeves I discovered during that project. If you put a comment that includes a parentheses, that will still be interpreted by the parser, but it does at least give you a warning. If you do like an if, else construct, but you typo else if and don't spell it in the specific way TCL likes, which is different from Perl or Bash's, it'll tell you that else is an invalid command because I think it might have interpreted the typo of else if as an anonymous function or something. Anyway, it's really bad. I transitioned from that to using Perl, and I'd move all the logic out of the TCL script. So I didn't need to do logic in TCL. I'd get state from a device, I'd parse that state, I'd decide on a method of changing its configuration, I'd generate a TCL script that I'd then run with CLogin. So it got rid of a lot of the pain of TCL, but it wasn't that much. It was a big improvement, but there was still much more ground to be gained. I've cut back on abusing Perl and switched over to Python, which has a much more structured approach. I know it's possible to write clean Perl, but I can't write clean Python, so it's not going to happen with Perl. And then most recently, I discovered Trigger, which is a framework for interacting with network devices. It provides a fairly elegant interface to connect to devices, but it is very much a framework. It's something that I've built tooling on, and that other tooling can be built on either directly on Trigger or on the stuff I'll show you here today. And that has really improved the methods that I'm using and able to, So in terms of the steps that we have in the process of making change to a network configuration, first, I'm going to talk a bit about the approach that I use within the code that I've got, which is generalized whether you're doing reporting or making changes to the configuration. Then I'll talk a bit about the specific implementation of normalization. It goes a bit into detail on the Python code, but I think it's important to have an understanding of how that framework has been built. Reporting, which leans heavily on the normalization approach, and then we'll talk about customization. And I've built out in the presentation a concrete example of a new type of reporting that I did just for this talk to show how easy it is to take the the work I've done in understanding how these things work and carry it into customization for your own environment in a more, which is a little more straightforward than the groundwork that I've done. And finally, we'll talk a bit about some improvements that I'd like to make to the tool. I left out something important about Trigger before. One of the big advantages compared to CLogin is that it is able to connect to multiple devices simultaneously. And because of that, if you want to process stuff for 1,000 devices, it's a lot faster when you're doing them 10 at a time or 20 at a time, as opposed to connecting to them in serial, especially when they're over, some of them are over cellular connections or are not online and you're waiting for them to time out because they're not responding. Specifically, the approach that I've taken is to first collect the configuration and device state. So we're looking at what the running config is on the device, what its operational parameters on. Then to parse and structure that information so that we have a clean representation using objects, dictionaries of the device state, which we can then analyze and determine if there's changes that need to be made to the config. If changes are required for a device, then you make those changes. I also store all of the information I collect from the device into a repository of device information. It's useful when you're doing reporting because you can do reporting without connecting to the devices, so you can reference that stored state information if you want to see, how many devices have this specific config in place. You have the information local and you don't need to go out to the devices again. Inside the example code, we have 4 critical files. So we have router.py, which has the kind of core logic to this system. There's normalize.py, which is a script which actually will perform a normalization on a device. Report, which is a reporting script. And I have a device list with 3 routers with highly traditional names. So if we look at how that is, Okay, good. A previous presentation I saw in this room a few hours ago, the text was illegible. I think this should be pretty okay, but if there is a problem, please let me know. So I ran normalize. It found that it prompted to say, do you want to run all sites, because you can select a specific subset of sites. It chose to, I went forward with it, so I'm processing routers 1, 2, and 3. One of them is down, couldn't ping it, wasn't processed. And one of them didn't have the trigger ACL present on the device. And that ACL that we're validating is example code, permit 1.1.1.1. A lot of the stuff that I've developed is very specific to the device configurations in my environment. So what I have here is, a very generic example. I'll come back to that a bit when we talk about the improvements, though, because I think there are more common things that different people in this room might share and benefit from that could be done in a community way, even if a lot of things are going to be specific to specific to your own environment. So at the heart of the system with Trigger, which is based on the Twisted framework for device interaction, I have a callback processing. And the callbacks, the way that they work is we take the list of devices and we get the details about them. The returned information from that is then processed by a script that validates the device's state. And then finally, we initiate the normalization of the devices. So a device that needs a change is going to then build out the change to the configuration. If we, oops, just a second. Okay, so I've called out the critical elements of the function. So in normalize.py, we have the get router details, which is an instance of a trigger commando object. It's got a list of commands that will be executed, and each device is checked to see if the device is available, tries to ping it. If it's available, then it's returned for processing. And on the within the common router.py code, we have the actual show commands that will be run on the device. So we're doing a show run include IP access list, and we're getting a show ver showing us the version of the device. When we then take that information back to parse it, the information, so each device that was processed and the result set that was returned is run through the validate function. And the validate function is first updating information on when the device was last contacted, which is used in the reporting. And we call the validate ACL function, which goes through the results of the show run IP access list, splits that out, and uses a simple regex to determine if it's a standard or extended access list, and to get the name of the access list, which is added into a list of ACL objects known on the device. We then have the functionality that normalizes the configuration. So for each device, we call this normalize function, which is down at the bottom in the router.py. We look to see if trigger test 1 is present in the list of ACLs that were defined on the device. And if it isn't present, we set a variable that tells that the device does need to have its configuration change and append to the list of commands the changes that need to be made to the configuration. So if you have a bunch of different checks, and those different checks will see, if a change is required to the device or not, and all those things are built together into a list of commands to be executed on the device. When we actually go to make the changes to the device, we just go through the list of devices returned from that function, and if they do need to have their configuration changed, then the commands that were built for that device are pulled out and used as the commands to be executed on the device. And then finally, we validate the return from that to make sure that the right mem that's executed at the end succeeded. On that 1,000 device migration project, we ran into a few machines that when you saved their config reported that the flash was bad, which is always interesting, and I wonder how long it had been the case. Most of them were fixed with receipts, but not all of them. Finally, we store the state of the device into, in my case, I'm just doing it with a JSON object. I take the list of objects and I represent it as a JSON object. If you had a larger number of devices or you're doing something more advanced, a better storage mechanism might be required, but it works quite well for the scale of devices I work on and would extend up to tens of thousands of devices fairly easily. Admittedly, perhaps not with the smallest file. For reporting, the output is fairly simple. You know, you run report, it automatically will use all devices, and this report just shows, you know, the device, when the device was contacted, and the firmware version running on the device. And then I've run it a second time where I've selected a specific device to be accessed, and you see in the report the access time for that device has changed. So when you've got a large field of devices, you're not going to reach all of them every time. And knowing when information is from is extremely important in understanding its value or deciding how you want to act on it. So this slide should have come before the previous one, and it talks about that reporting process. Okay, so this is actually the overview of how that actual code works. So we load the state information that's present right now. We identify the devices that require updating. We connect to the devices, we get updated information about them, and we generate the report for them. And you'll see that there's a lot of commonality between the normalization process that I reviewed before and the reporting process now. So we're using most of the same functions that were present in the core router.py code. We just don't do the normalization. So we're doing the same validations, it's using the same validation code and the same commands to collect information, but we don't need to make any changes to the device. So we have code to output a CSV, which is pretty straightforward, goes through the different routers that are present, and writes out when they were accessed, the device name and the version. We speak about adapting this to your own environment. There's a lot that you can do with this to take the framework that I've made and to implement specific things that you're interested in, things that need to be validated in your own environment. I suggest that you work first on creating small tests that are exploring individual and smaller elements of what you're interested in doing, and then build from that over time. You can also bring in information from other data sources. So I do a lot of stuff where I'm pulling information from monitoring systems about historical device availability. You, in larger environments, probably already have decent repositories of information about your network environment, and that all can be pulled together and in. So what I built as an example of how it's relatively easy to extend is something to parse which ACLs are applied to which interfaces in a Cisco or Cisco-like device. And this single slide actually shows the entire change that I made to do that. So it is a lot easier to add things on top of what I built than it was for me, at least, to build out that initial example. So I've added in a new show command that looks at the running config and gets the interface sections. And then inside the validate function that we're calling to validate device state, I've added in validation of the interface, a new function called validate interfaces. And inside there, we create a dictionary of interfaces. I clear it at the start because I had some bad experiences with interfaces being removed that because I didn't rewrite the entire object each time, it would cheerfully report really old information about interfaces that were no longer on the device. So that is important. And then in the config, I go through the show run interface sections. I pull out the interface names. When you find an interface name, it gets added to the interfaces. And then we build for each interface, if it's got an input, an inbound and an outbound ACL, those are sort of recorded into a dictionary underneath that for the specific interface. I've only done ACLs here, but obviously this could be extended to all sorts of different stuff, IP address configurations, QoS configurations, and this is kind of something where there's a lot of, this part of the validation is something that a lot of different people have the same needs for, as opposed to how you take this information and validate its relevancy to your own environment. So we have the output from it, and I ran it against one device, and we can see that the gigabit Ethernet 0 interface has an inbound ACL of test applied to it. There is a lot of room for improvement in what I've done. One thing is, I've done a manual job of building this interface parsing code, but first, a lot of it is stuff that could be applied to any device in any environment, and it's something where there's more common code that could be created. And there's also a Python library called Cisco Conf Parse that will build a representation of a Cisco or Cisco-like device configuration kind of automatically. It doesn't have as much understanding of how it works as something else might, but it understands hierarchical command configurations and nested devices under each other, and it's supposed to do a pretty decent job. I haven't really played with it that much, but it is something that would be pretty cool. A much larger thing would be the development of a domain-specific language. So right now, all of the stuff that I've done, you need to actually understand Python. And unfortunately, there's lots of people that know Python. There's lots of people that know networking. But the overlap between them isn't necessarily as strong as it could be, unfortunately. And there's not as many people that seem to be, fluent in both, we could say. And bringing it to a domain-specific language could make it easier for networking people with less programming ability to work on this type of system and to benefit from it. You also need to avoid creating a domain-specific language more complex than Python, which, well, I think we've all seen examples where that could have gone better. Finally, another big area for improvement would be more community involvement. So I did this. I was fortunate enough to be able to kind of contribute back open source portions of the work that I'd done. And I'd like to think that there's other people that are interested in this subject that might also be able to work on this both for their own internal use and outside. There really doesn't seem to be much public work done in the network automation space, and especially with open source tooling. I know that there's a lot of people doing stuff behind closed doors and that there's things that can't be shared with the outside, but I think there's also a lot of room for more improvement and more change. And I hope that this talk will maybe get a few people interested in it, and that we can start to build more of a community around this and other related projects. I have many people to thank for being here today. First and foremost, my wife, my kids, my family, who support me and put up with me and other stuff. Jathan, who created the trigger language framework and was able to also make that an open source project and available to other people. Without people doing open source work, there's nothing for other people to build upon. Stack8, who's given me a great place to work and to develop my own skills and ability. My good friend Henrik, who helped me with Python and actually didn't want credit here because of the quality of my Python, but I try. Charlene, who really turned this from a much more bare bones presentation into what it is now, the Trigger community on Freenode, and my friends in the Linux channel. Went through that a little, and if you'll wait for the microphone.
Why use Trigger and not use something like Ansible?
And not which, I'm sorry?
Ansible?
Ansible? At the time that I did it, I don't think that Ansible had the support for the Cisco stuff. Also, I found it very, very hard to find anything on the subject. So when I was doing the C login stuff and hating it, I was looking for people doing this kind of work, and I eventually found Jathan's presentation from 3 SCaLEs ago that spoke about trigger. I recently did learn about the Ansible Cisco integration stuff, like the bare SSH support stuff. I'm interested in checking it out a bit more. And really, while I'm happy with the work that I've done with this, I'm also open to other approaches. I'm looking for the best possible ways to do this. I'm looking for the best ways to scale it. I'm looking for devices, things that are more cross-platform, and the more stuff that I can do with it, the better it is. I heard about some interesting stuff involving SALT and network device automation as well, and I'm interested in checking out all that stuff. So while I'm presenting on Trigger today, and I'm very happy with what I've done with it, doesn't mean that we couldn't be talking about something else in a few years.
This is not a question, but I did some stuff with Trigger where it would log into devices and parse gigantic config files. And a problem in general with some of these devices is that there's no grammar for and you don't necessarily want to write a grammar. There's no, codified grammar for things. So a lot of these things will actually dump XML, and if that's available, I would definitely recommend using that versus trying to parse.
So
I
know that Juniper devices do that. They have fairly strong XML support, as I understand it. Unfortunately, I haven't had much opportunity to work with that.
Yeah, no, I'm just saying if it's available,
obviously something that gives you a structured form of the configuration of the device would be preferred. I know that Cisco worked on some stuff with 1PK, which was supposed to be this kind of platform for automating their devices, and I went to a presentation in their offices in Montreal, and many people were there for the lunch. I was there because I was interested in what they actually had to say, somewhat to the astonishment of the presenters. What I found, however, was device support was very limited, and on a lot of non-Nexus devices, it was also necessary for you to run T-train releases. Cisco subsequently
Oh yeah, no, I'm not saying it, like everybody does it. I'm just saying if it is available, it can save you a lot. And sometimes when you're parsing, you can go line by line, but in some cases the configs are involved enough that you actually have to parse it, into a parse tree and try to suss out like this ACL is attached to this device sort of stuff that, is difficult to do without doing a full parse. And Jathan can speak to this too, but I mean, like they've done parsers that ended up being sort of Franken parsers for multiple devices, but it's difficult to say, is it correct for any particular device, right?
In Trigger's method, you do have a method of when you define the device, and I didn't really show the details of the CSV file, you also state what platform it is or what family of device it is, and that can be used to drive both how you connect to the device for devices that have like non-SSH support, and I'd imagine you could kind of feed that information back in other ways as well.
Yeah, no, I mean, there is parser support. It's just getting to the point where it was like, oh, this is a little different. Oh, that's a little different. We'd actually talked about splitting it into, very manufacturer-specific parsers. Anyway, that's getting it.
You mentioned that and I apologize, I missed part of the first part of the talk, so maybe you covered this, but you mentioned that you were looking at other open source options, or you didn't find any, but I was wondering if you looked at any of the prior work, such as netconf and yang, which are standards-based protocols for manipulating configs on devices, or even some of my colleagues are working on OpenConfig, which is an evolving standard right now, which is actually documented and available for driving device configuration in a vendor-agnostic manner.
So unfortunately, I did not hear that question very well at all.
Oh,
and I
sure.
think that the speaker facing is much better for the audience than the presenter. But I did hear you mention netconf.
Yeah, so I mentioned netconf and yang, which are sort of prior art from like 10 years ago on sort of programmatically driving device configuration. But I was also mentioning OpenConfig, which is a new standard protocol, that's standards-based protocol that's being developed for device configuration in a vendor-agnostic way.
I haven't heard about those before, but I'd be very interested to check them out. And maybe if you want to approach after, you could tell me a bit more about it. I'd welcome it. Any other questions? I have a bunch of references, starting with this presentation, which should be online on the website shortly. And I've got a relatively short URL if you want to grab it here. I've got a direct link that leads to the example code, which is in the GitHub Trigger repo, the documentation for Trigger, as well as the Trigger GitHub project page. For people that are doing, for people that don't know Python but are interested in this subject, I pulled out one well-known Python guide, the Learn Python the Hard Way, which apparently is actually the easy way to learn Python. And it's supposed to be a very good approach to Python, especially for someone who doesn't necessarily come from a programming background. I think that if you do have programming ability, Python should be fairly easy to pick up if you don't already know it. I've got my website and my email address and my employer, Stack8. If this stuff sounds interesting to you, but implementing it in your own environment sounds hard, we could also talk about that. And finally, I got all the graphics from this for this presentation from a website called flaticon.com that has a lot of really nice, clean little glyphs, great for presentations, other stuff. Here's the licensing on the different files. Thank you very much for your time. And if you're interested in talking more now or at any other time, I really am interested in learning more about this, and hopefully other people have things to share too.
Testing, testing. Testing, testing. Hello, hello. Testing, testing. How's the volume? Can you hear me okay at this level? Good. Okay. How about that? Is that okay? All right. Cool. Again, my name is Dave Boucher. I work for SaltStack, and I'm really excited about this talk. It's a fun one for me. It's kind of a crazy stuff you would never do in production or in real life, but kind of give you an idea of, a greater vision of possibilities of things you can do with salt. So, who here has used salt either in a testing or a production environment? Okay, so about 80% of us probably. Grumpy guy's shaking his head. Yeah, he does. Okay, so I'm going to just talk a little about some of the very basics, some of the general use cases of salt, the people use salt for. And then I'm going to talk about some of the other pieces of SALT that people often kind of miss when they think of config management. They don't realize there's so much more to SALT than just that. And I have a couple demos that will be interesting. And so get to use your cell phone. If you have a cell phone signal down here, mine it doesn't, unfortunately, but we'll be able to. Everybody will get a chance to participate. So beyond config management. All right, so SALT basics. There's generally you would use SALT with running a SALT master that controls other servers that are running an agent called the SALT minion. If you have a situation where you don't need a constant connection to your servers, you can use SALT SSH to have SALT work across SSH in a like one time or not have that constant connection all the time, but just go over to SSH when needed. So this is kind of what they typically would look like. So you have your SALT master, you have a couple of minions here connecting through ZRMQ, and then also SALT master reaching out to one server through SSH. If you'll notice, the arrows are pointing from the minions up to the master, because when you're using ZRMQ, SALT uses a pub sub interface, and the minions actually connect to the master. So the master needs to have 2 ports open for the minions to connect to, and the minions listen on that publish port. Whereas when you're using SSH, SALT master does reach out to your minions and does things. When you're using ZRMQ in this pub sub interface, that allows SALT to scale into the tens of thousands of servers because the master doesn't have to specifically manage every server that's connecting to. So that's why it's done like that. You can also use the SALT minion by itself, so with no master at all, so everything's just done locally. Sometimes I'll do that on my laptop. I don't want, sometimes I'll have a master and a minion running on my laptop, but other times I'll just use the minion by itself to configure my laptop. People do that in production as well. If for some reason they can't or don't need a SALT master, they'll just use the SALT minion by itself and do all the configurations locally. They'll pull them down from like S3 or other locations. A syndic allows you to have hierarchies of masters. So you could have a top-level master that can see everything in your entire infrastructure, but then maybe you have a lower-level master in different data centers, or maybe different business groups have their own master down below, and that allows you to have kind of high-level view from this top master, but lower-level control down below. It also helps with scaling as well. Minions can also talk to multiple masters. So you can have a multi-master situation where they'll accept commands from masters. Some people use that for a kind of poor man's failover type thing for your master, or also for different people needing control or visibility into your servers. So advanced SALT features. One of the things that really differentiates SALT from others in this space is that fast, encrypted, dynamic connection that your servers have between the master and the minion. So we have an event bus that runs locally on the minions and also runs from minions up to your master. So events, things that happen on your SALT infrastructure get passed up to the master for various purposes. SALT itself sends lots of events, so when a minion starts up, when a new minion tries to connect to the master, there'll be an event. There's a whole variety of things that would cause an event to be sent up to the master. You can also send your own events. So you can have your own application send an event to the SALT master. There's a whole variety of things you can do with that. One of those things is a beacon. So a beacon is a small service that will run on your minion that will monitor something. So we have beacons that will monitor your file system, that will monitor your SSH logins, a whole variety of things. And we'll be talking about a Twilio beacon that monitors a Twilio text message queue and then send an event on the event bus. Reactors and engines. So the reactor sits on your SALT master, and it sits there and listens to that event bus and allows you to do things, react to those events. So maybe there's that one stupid application you have to manage that needs to be rebooted every time it hits a certain memory level. Maybe you can check for that, and instead of having to manually go in and do that yourself, an event gets sent up to the master saying, hey, this dumb application needs to be restarted, and then the reactor sees that event, restarts your application, and moves on, logs it somewhere, and barely a hiccup. Just a simple example. And engines are similar to that. They're a Python interface, so you can create your own little programs that will listen to that event bus and do things in Python. So there's a little more flexibility there, your Python. Tonight we'll also use a Salt API. You can turn on a REST interface that allows you to reach out to Salt from any other application and do things with that. So if you have an existing CMDB, an existing application that manages things on your network, now Salt's all the possibilities of Salt are now available to your application. So you have a Python interface as well as this REST API, and really makes for some really interesting use cases there. So again, we'll demo that a little bit today as well. So again, it's just kind of like an overview. You have a minion here, beacons and engines run on the minions, reactors, engines as well, and the API run on your Salt master. Okay, now we're going to do live demos. So, yes. All right. I had to rebuild the server last night to make sure everything works smoothly. So, so you see here, what's that? Yeah, exactly. All right, so you're probably all. I think after 4 years, I would remember that. Okay, so I have a master, I have one minion that I'm controlling here. And most of you are probably familiar, we have this whole slew of modules that you can run. So on all my minions, I'm going to run disk.usage. We're going to get that data back, almost instantly. Yeah, do we have, actually I could probably increase the. Better? All right. This is how we work at Salt anyways. Over in the engineer section, all the lights are off like this. So you can see, you can also get that data back in different formats. So say I want that in JSON so I can ingest that with some other tool. There's that exact same command, output it in JSON. You can get it in raw text, in the raw Python data structures that it comes back in. Everything in Salt is a data structure, so that allows you to do a whole variety of things, including manage the output like this. You can also do command.run will allow you to run any arbitrary command on your systems here. And that was one of the things that got me really excited about Salt originally when I first found out about it. Was just I felt like I had this power. I mean, finally I could reach out and know what's going on the servers on my infrastructure. What's the disk space looking like? There's this one server that we're constantly checking. We have monitoring, but what's going on right now? You can run these commands, get that data back, and do something with that really, really fast. In fact, the remote execution was built first. When Salt was first written, it was just all it was remote execution. And that kind of informs the rest of Salt. All the Salt states, all the event bus, everything is based off that initial remote execution that Salt provides. This is a brand new server. So if we want to run a Salt state, just for those who haven't seen one before, let's do an Apache server here. Okay, so here this is a simple Salt state. Apache 2 is the ID declaration, which also will become the name of the package we want to use. we have a package state, and installed is the function that we're going to call. And you notice it's installed, so if the package is already there, it won't do anything. But if it's not, then it'll do the right thing. So let's install this thing. So we'll run the state.sls Apache server. And the amount of time it's going to take here is mostly just apt checking to see if Apache is installed, and then installing it here. So I know for a lot of you this is like the very basics, but I just wanted to kind of give a quick overview of how this works. Yeah, probably does. He mentioned it was probably doing an apt update as well. So that's a simple salt state. Okay, there we go. Done. It took 32 seconds. Installed all the dependencies we can see here. Again, this is all a data structure, so I could have gotten this back in JSON, but you can see here we got the new Apache 2, installed all the dependencies, and gave us information about that. Now, at any time, I can run that again, and it will do the same thing. It'll check to see if it's installed, and it already has it installed, so it's not going to do anything. I can also, here on the command line, just come here and do and we'll do a package.purge. And when you're on the command line, I'm using the actual execution module, and this is actually going to do this. It's going to remove that package. So there we go, we're done. A friend of mine that runs a bunch of the websites for the major newspapers in Salt Lake was on a train heading home when Heartbleed was released a while back, and he hopped onto the crappy Wi-Fi on the train, ran the little check using this to see which servers were vulnerable to it, got that list, ran the command to fix all of them, and it was done. And the whole process, took 6 seconds to actually do. So you just seriously, that's one of the things literally that got my attention about Salt was the just the fast control that you had and the simplicity. Yeah. Okay, so now I want to talk about beacons. So a beacon, like I mentioned before, is a little service you can start on the minion that allows you to watch something. So I'm going to set up a beacon that will watch a specific file for any changes, and when it sees a change in that file, it'll send that event up to the master saying, hey, this file changed. And I'm going to set up another one that will look in a directory and notify any changes there. So if I come in here, so here we have our beacons definition. I'm going to use the iNotify beacon. This does require I think it's Python notify Python module to be installed. So any event, anything that happens to this serve/blah.txt file, Salt will send a message up to the master. For this /serve/testing directory, I'm just going to look for the close write event and send an event up to the master. And we're going to recurse through any directories that are created. We're going to auto add any new files to it. And then the interval says we're going to check every 10 seconds. Okay, so down here, I'm going to start a little listener. So I can see what's happening on the event bus. This is a great way to see what's going on when you're debugging. So let me go into /serve directory. Here's that blah.txt. So let's open this thing up. And another line, we'll close that. And then you can see right there, we got a notification that, increase that size a little bit, that that file was modified, the change that happened, and the path to the file that happened. Go into that testing directory. So let's create a new file. You can see here in that /serve testing directory, we had our close right. Another right, another close. You can also see there the swap file that Vim created was also modified there. So what could you do with this? Let's say you had some little sysadmin that just will, or some developer that will not stop logging into production server, start editing files, it's always getting in there and modifying things without going through your change management. You could watch your Etsy directory, and anytime there's a change, an event was to be sent to the master, and you could clobber it and say, nope, redo it. We had one of our clients did the same thing with yeah, you can send an alert through PagerDuty, announce it to the world. You can also check for like SSH logins and things like that. So someone logs into a production web front end that you should never do. You could just log them out and kick them out right off the server immediately if that case. Or you can just notify PagerDuty, notify their boss that someone was misbehaving. Do you have a question? Uh-huh. So spam half the company when somebody modified a file when they shouldn't be. Automated pink slip, I guess? I don't know. Krister. Yeah, so all this does is it sends an event on the event bus. So then you can use an engine or a reactor to do whatever you want to do. So it could be anything. It could be a add something to your CMDB. Oh yeah. Yeah, exactly. So Krister was talking about his security module for checking for file integrity. This could be part of that. You know that files shouldn't be changing at 4 in the morning, and you can get a notification. Then you can log that, however, in whatever monitoring system you have. Depending on the file, maybe do an alert if necessary. Just gives you visibility into that. There are a variety of modules. So if we come here to the beacons section, so we have a disk usage beacon. This one allows you to set thresholds for notifications to be sent. So you can say, hey, if you ever get above 85% on these specific file systems, send us a notification, that type of thing. The iNotify that we saw here, journal D for system D. Same thing with load. You can do your criteria when you want to send a message. People sometimes will use that for load balancing, that type of thing. Certain server gets maxed out. You get above so many, your load gets so high, it lets me spin up another VM to help manage the load. Services that are PS for services that are running, a whole variety of things. So WTMP is for your logins, that type of thing. So and we're going to use the Twilio text message today. And let's look at that code for these. You'll see that these are extremely simple. So if I come down to this Twilio thing here, you'll see that we have some documentation, we have some imports, we have a validate function, and then the only requirement you have is that you have a beacon function. You can see here we have our documentation. But this is the entirety of, so that's 30 lines of code, including logging and nice, clean formatting to check for these text messages, as well as to check to see if they have images and things connected to it. So if you had a beacon, you had something else, say you had an application that you wanted to monitor locally on your server, you very easily could create your own beacon to run your checks and send events as needed. Any questions on these beacons or anything? Sure. Yeah. So the question was, could you have a beacon that would watch a log file, and then if there's a specific error, notifies syslog or something like that? You definitely could do that. Okay. So here we have our Twilio account here. I think I exposed my account credentials in the previous when I opened the file thing, so I'll change those before we this gets on the internet. So yeah, I do. This is live streamed? Okay, well, we'll be changing that quickly. Again, it's in the interval. This WTMP, again, is for if I want to check logins. So actually, the first time I gave this talk, I had a guy from Apple in the audience. I didn't know he was from Apple, and I forgot to take it off my server. It's like for the next day and a half, he kept getting text messages that I had to think, so if whenever somebody logged in, it would send a text message to a person, and he texted me back, he's like, hey, could you take me off that server? So those are beacons. And again, you have reactors and engines that can do things with those events. So in the demo that I'm doing today, I'm not actually going to use a reactor or beacon. I'm going to have a little web page that the Salt API is going to expose. And the JavaScript is actually going to bind to the event stream and listen for events from my Twilio account and update the web page when that happens. So just a quick view of this. Friend and coworker Seth House actually wrote this in like 4 minutes for me. He's more of a JavaScript guru than I am. Where are we at? So here we're going to listen to the events on this event source, and then when we're going to update and create a new module or new elements on the web page. So let's see what that looks like. Sorry, I'm losing track here. Okay, so here's our simple web page. Also promoting SaltConf in April. You got to come out. It's going to be awesome. A few of you have been to SaltConf. And it's a good time. A lot of learning, and it's a really fun conference. And is that you? No, it wasn't you. I'd be giggling. Oh, that was Charles in the back. So if you text that number up there, you'll see the text will show up here. If somebody wants to send a you can send a picture text as well. Please keep it G-rated. This will be on the internet, but somebody wants to send a picture of not of my zipper down, please. So again, what's happening here is my server is running a little beacon, and it's checking every 5 seconds that Twilio account. And when it sees a text, it sends an event on the event bus. And there's a multitude of things we could do there. You know, we could have reactors happening, and you can do many things with each event that comes through. In this example here, we're just listening to that event stream, And on the Twilio ones, oh, that's a big one. Yeah. Here, kitty, kitty. And we're just dumping these to the web page here. So obviously you wouldn't want to do this in production, but maybe you have a monitoring system, you have PagerDuty, you have there's a whole variety of things you might do to monitor things, and you can listen to these events and do things with that. Any questions about this stuff so far? Yeah. Good question. So all I did was added that config file for it, and then restarted the menu service, and it'll process all the beacon definitions and do that. So, yeah. Oh yeah. No, you easily could have that run. You could see that event, take that text of that event, and use command.run from the event loop and do that. Yeah, so obviously all of the security precautions you would take, accepting input from external sources, you would want to do here as well. Yeah. But this kind of thing you could do, if you have like a chat ops type scenario, people want to deploy, from Slack or from IRC or something like that. You can do that with Salt. You could also set it up so they could text something and deploy from Salt. We had a customer that had this Windows application that would frequently lock up, and we worked with them with their first line tech support. And it was a pretty simple thing to do, but their first line tech support people weren't technical enough to actually log in and restart this thing without screwing things up. It was very difficult. So they kept escalating it to someone who could do it correctly. But it was fairly frequent, and they had a lot of customers that would call in and do it. So we worked with them to add just this red button in their thing. And so the first level tech support could log into the customer's account and say, hey, my thingy, whatever's not working, and hit that button. And that bottom one there scared me when I was a kid. Dave. Yeah, so they just hit this button, and the higher level tech support people never had to bother with that again. They would just hit that, and they gave them the ability to take care of the customers without having to manually go in and fix their problems there. Okay. So I was going to text from here as well. I usually would send it from my phone, but I get no bars in here at all. God, which screen am I on? Oh, there we go. So. All right. Any other questions about this here? All right. Is there anything you want? Yeah, go ahead. Sure. Should we get to the microphone?
Hey. Okay. First of all, the message queuing model that SALT uses seems to be quite different from any of the other configuration management systems that I've seen. And it, as I understand it, scales extremely well. What kind of volume can you actually handle in terms of agents that are connecting into that message queuing system for simultaneous processing on large fields of devices?
Really good question. So it's one of those things that kind of depends, but we have people that are using up to 18,000, close to 20,000 minions connected to one master. There are some difficulties when you get to that scale. Sometimes just the flood of data that's flying back. Your NIC can't handle, your operating system can't handle that much data. But there's ways to ameliorate that using Salt Syndic. So you have lower level masters that handle all the cryptography and communication with the minions themselves that then wrap up all the results and send them back up to the higher level master, that type of thing. But places like LinkedIn, I mean, they have, every time I talk to them, it's like they're bigger. But like one point they had like 30,000 servers, and I think they're like 100,000 servers now. Not necessarily all of them running off one Salt master, but a couple of different masters there. So, I mean, it's really common for people to run Salt on like 1 or 2, 3 servers, and then we have a lot that are in the 5 to 8,000 range, very comfortably.
Cool. I'm also very interested in network device configuration management. I don't know if there's anything you can speak to about SALT being used in that kind of a context?
Sure. So we have some modules that will reach out to network devices and things. There's a somewhat new feature of SALT called a proxy minion that runs on a regular minion and allows you to take like say a network switch that you can't install the SALT minion on or something like that. With Adobe, we're working with them on I hope I can mention this, but on a module to talk to some server hardware so they can configure the hardware and then bring up their the servers and that type of thing. So this proxy minion allows you the proxy minion handles the communication with the device and then allows you to use all of SALT's modules and things like that as if it were a server and that type of thing. You have a small subset of, it's things that make sense on that type of hardware. Yeah. Yeah, you're welcome. I could actually get that to work. It was, emoji were actually breaking it because I was trying to cast everything to a string, and so it was actually breaking so I had to go in and hot patch that code. You're getting close to the line, people. Go ahead.
When I run a command against all my minions, which I don't have that many, like maybe 60 or something, the first time, if it hasn't been run in like a while, the first time a couple of the minions fail to respond, but then like if I hit it again, everything will be fine and happy for the next while as I'm using it. Is that normal? Are they like sleeping minions?
You have to kind of warm them up.
Exactly.
So what happens is, by default, every 24 hours, the SALT master will rotate its encryption key that it uses for the communication on the publish port. And if the minions haven't communicated with the master, anyway, so the next time, when that happens, the minions have to, when they connect to the publish port, they can't decrypt the load, and so they'll request a key refresh. So if that happens like at midnight, and your minions haven't talked to the master, at 8 o'clock in the morning when you log in, the first time you run a command, it can throw that off. So there is an option. So that's what happens. So you have to like run like 2 commands to get them all working. Right. There is an option to have the master do a test.ping after the key refresh, so that it automatically updates all the keys like that. But that's what's happening there.
Also, is there any kind of testing framework for SALT?
So SALT tests itself internally, because states inherently test themselves to an extent. But we don't have an official framework yet. We're kind of working on ideas on how to do that well. There is a plugin for Test Kitchen that employee of Hewlett Packard wrote, so you can use Test Kitchen, which is a chef tool, to use SALT to test your states and build up a VM with all your states and then make sure that they're behaving appropriately. Some of the ideas we have with that is to be able to specify success parameters right next to the actual states themselves. So as you build out your states, You can specify, you know, if I spin up a web server, when I access port 80, I should receive this type of text, that type of thing. But it's still kind of in the design stage at this point. And I'm not sure, yeah, I'm not sure if that'll even be gotten to this year. So for the moment, that's all we have. So, any other questions? Go. Pardon?
Are you going to be talking about the event reactor?
Would you like me to? Okay. See, you get immediate audience feedback. It's awesome. Yes, and Utah Dave is my IRC handle. I'm Utah_Dave on Twitter because there's a real estate agent that has Utah Dave. He actually yelled at me on Twitter once, "Who's using my copyrighted nickname or whatever?" I've been Utah Dave. Yeah, mashed potato. Actually, don't have any on this server. So a reactor is a simple YAML file that sits on your master, and you specify a tag that you want to listen to. And you can use Jinja to look at pieces of the data structure of the events that are coming through and do things with it. Now, when you're creating these, this reactor loop needs to be really, really fast. So you do have access to Jinja, which means you have access to the Salt modules and states and all that kind of thing. So technically, you could run Salt commands and various things from there, but you do not want to do that because you want the reactor matching on these tags really, really fast. Because then when it matches a tag, it'll spin off another process, another worker process to actually run the commands you want. Okay. All right, so here is a reactor that was listening for the Twilio thing. Or actually, no, actually this isn't. This is actually to send an SMS. So in the other demo that I was doing where every time somebody would log into the server, it would send a message saying so-and-so logged in. So what would happen? So this first thing here is the ID declaration. So it's just a name I made up for this. It could be anything you want. Local means I'm going to run a Salt execution module, which is Twilio send SMS. Target is going to be Boucher, which was the name of my server. So that's the name of the ID of the server I had. Had to pass in some arguments. My Twilio account, it was just the arbitrary name I'd given, the credentials that's from a Twilio account. And then this thing here, the information from the event that was sent is inside this data structure that's inside of Jinja. So this double brace indicates we're inside of the Jinja environment. So I'm going to get the host name. It says host name logged into, and then the ID of the server, and then the timestamp. I'm wondering if I had that. That's wrong. Seems like it. Yeah. So, yeah, I haven't used this in like a year, so I'm not sure if that should work. But essentially, I'm creating the text that we're going to send in that. Okay. Yeah, so I think this could also just be name. Depends on the data structure. So I would have to look at the data structure that gets sent when someone logs in. So if it was just name, for example, that's essentially the text that we're sending in the data. I'm sorry, in the text we're sending. And then this is the 2. So that's my cell phone number. and then this is the from. This is my Twilio number. So what that means is this gets called whenever a specific tag is met. So if we come in here, so in your master config, I don't have one right now, so actually maybe I do. Yeah. So in your master config, you would have something like this. So you have reactor is the initial config section, and then you have a tag you're going to match on. So in this example, the tag is salt, minion, and then we have star, which is an actual wildcard. So in reality, when a minion would start up, you would see like minion 01 there, where that asterisk is, and then start. So every time the master sees that, it will call first this start.sls, and then this monitor SLS. So in our example here, we would have a reactor, and then we would look for the tag that came up for that login beacon. So you can also send your own events as well. So here's another example. When you get an event with a specific key, we would take that key, delete it, with this execution module. So really, you have the full power stall to do whatever you want. So you can run stage, you can do a whole variety of things. So if people use reactors to fix problems that have known solutions that happen regularly, the application developer just won't fix that thing. You can have Salt fix that for you. You can send events, so if something happens, you can have it fix that.
So, in the reactor states, when you have that, you have multiple ID declarations. Do those fire in parallel, or do they fire in parallel?
They fire in order. So they start at the top and then move its way down. You can also do things with engines. I haven't actually had a chance to use engines yet, but they allow you to create a Python interface. It's like your own little program, so you can do whatever you want within this little Python program. Let's see, there was... Oh, I was going to show something else. I forgot what it was. Okay. Anyway, that's pretty much it. Yeah. Well, they're more complementary than either or. So a beacon is the thing that's actually checking your file system, and it generates an event. So it's dumb in that it doesn't know what's going to happen. You don't have to configure a beacon to do anything. It just check this thing, check it, and then send an event when the conditions are correct. And then you would use a reactor or an engine to listen for those events and then do something. So that way you kind of get a separation of concerns, because you may not want the beacon running on that server. It could be in a semi-hostile environment or something, or you may not want it to even know what's going on. So it would send an event, and then the master would take care of doing something.
Okay, so master runs the reactor.
Yeah, master always runs the reactor. Actually, you know what? I think you can run reactors on minions now in standalone mode as well. But in the general case, the master runs the reactors, yeah. So, great question. Okay. Well, that's pretty much the end of my talk. I'm willing to stay and answer questions. Yes? So the question was, when would you use a reactor versus using an engine? I think you would do that when you need more programmatic control of everything that's going on. So when you're using a reactor, it's simple in that you just have, the reactor listens for a tag and then executes this list of SLS files. And then those SLS files are still essentially, YAML with some Jinja. And, for more straightforward things, it's pretty easy to go. Sometimes it can be a little obtuse trying to figure out the data structure of the event that came up, and that can be a little tough. Whereas when you write an engine, you're basically, you're just in Python. So you kind of you get to decide all the flow of that, of what's going on, and you get more programmatic control. Whereas, my experience has been, if you're doing a lot of Jinja templating and things like that, I like to keep it at a minimum. If you're doing a whole bunch of it, you're going to get into a big mess and give you a big headache. And so if you were doing complex things, I would look at using an engine. And you'd probably get to define what complex means to you, but that's kind of where I would do that. Yeah, sure. Mm-hmm. Okay. Great question. This question was, he mentioned that there's a lot of configuration management tools out there, and what led to the creation of SALT and what are the main differences with SALT. So Tom Hatch was the founder of SALT. He worked for first for a lot of large federal government agencies managing large infrastructures, and also worked for a music startup that also had some large infrastructures. And there are a couple things he just craved as the systems architect. Was one, to know what's going on with the servers. They would keep track of servers like in a CMDB or just in a spreadsheet, and it was always out of date. Right? Everything should have this version of the software, but you go check in reality and things that happen, people had updated things, some things auto-updated. You never knew what the current status was. And so he really wanted to be able to have that remote execution. He wanted fast control over his servers. That was kind of some of his main desires there. And he had used basically all the tools that were out there at the time too. And so that's where SALT started, was the really fast remote execution. And that's one of the things that SALT stands out with, is it's really fast remote execution. It's not just bolted on after the fact. It's the core part of what SALT is. SALT is also very pragmatic. So it's very rare. I've done a lot of in the past, the first few years of SaltStack as a company, I did a lot of the professional services, working with, big infrastructures, JP Morgan Chase, LinkedIn, various places. And, I didn't work on LinkedIn's infrastructure, but worked with training on them and things. And it's rare that you can come in and just be like, everything's SALT. You always have people that are like, well, this little team over here, we're using Chef. We should use Chef to configure our servers, and we're not changing anything. We're not touching it. It's not going to happen. And then there's other teams using another tool, and this other team has their own homegrown Bash, Python, Perl behemoth that they've got going. And it's rare that you can just swap it all out. SALT makes it very easy to use it where it really makes sense for your infrastructure. It's very pluggable. So both from what SALT can do, if SALT doesn't do something you want it to do, you can create a new module and state for it very, very easily. If you have, especially for an execution module, it's very, very basic Python. People that never programmed before, people that are experienced in other languages, the Ruby developers, it's very straightforward to get involved with Python. But also connecting to Salt. So we have a whole bunch of external authentication modules. Some people in this room here have written their own external authentication modules, pulling data, configuration data from their existing CMDBs. Krister, they have their own CMDB that they had written, and it's not going anywhere. That's the source of truth for a lot of what they do. And you just wrote a module, and now Salt pulls data out of their CMDB, and it just fits right in. So it's very easy to tie into everything that you already have existing on your infrastructure. We have Puppet modules and Chef modules that allow you to do Chef solo runs and Puppet runs to manage it. Wikipedia does that. They use Salt to orchestrate all their code releases and all their Puppet runs, but they have something like, I don't know, last time I talked to them, they had something like 30,000 lines of Puppet manifests, and they just didn't have the time or really desire to swap all that out. And so they use Salt to manage that, to scale their Puppet stuff out. We have Ansible, what do they call their list of servers? Playlists? No. Pardon? Not the playbooks, but their list of servers they have that they run commands against. I'm drawing a blank, but you can use Salt. Salt can use those to run commands on servers. We're very pragmatic about integrating with everything that you want. So there's something like 15 or 16 different pluggable interfaces that Salt lets you touch and add on to if you need. One of our big customers here in San Diego, they're spending something like $5 million a year on their previous configuration management software that they were using, and they swapped that out for Salt. And the fact that they could get to the source code and they basically entirely revamped one of the modules. So everything else pretty much worked great for them. There's one module that just wasn't quite doing what they wanted. The fact that they could get on, do a pull request, and make it work right and fix that bug was just fantastic for them. They just, they loved it. So they have the support of SaltStack as a company, but their expertise that they have on staff, sysadmins, and developers can go back into Salt itself. In fact, a lot of times when you're running code with Salt, you're running code that, experts at LinkedIn that are managing 100,000 servers, a lot of the scalability that SCaLE has was based off of some of our larger users running into things at scale, because we don't have 100,000 bare metal servers sitting around in a closet there at SaltStack at their headquarters to test against, right? So a lot of the best practices and lessons learned from some of the top people in the world, get all that experience flows back into Salt. Like the reactor, so there's some people here in the room that I was working with them, and we were working on re-imaging. So they had a tool that could re-image a server and just completely, put a whole new OS and change it from like an application server to a database server or backwards, or vice versa. So we're working on automating that. Then it occurred to us that well, maybe what happens if something goes crazy and suddenly it's thinking it wants to re-image 400 database servers? That could cause a major problem. So we added in a queuing system. And I'm not sure if we actually got that fully implemented there, but added in a queuing system that would allow you to add things to a queue. So if there was 5 that need to be re-imaged, okay, that's normal. But if suddenly there was 400, you could say stop and do that in an orderly way. And so I don't know. I could go on and on, but there's really, I've done professional services with some incredibly talented people, and I've never used a tool that was so flexible. There's I've hardly ever run into a situation where Salt just could not do something. That's correct. So even in our enterprise software, Salt itself is Apache 2.0, completely open source. And for a couple of years, we actually provided packages specifically for our enterprise customers that we supported directly. And we're moving to a framework instead that they'll basically use the same packages, but we're building a tool called RAS and a web GUI associated with that sits on top of your masters that will allow you to, at this really large scale, to keep all that data and scale out to the tens and tens and tens of thousands of servers and view that at a pretty massive scale. So that allows us to provide value for our enterprise customers at these difficult large-scale situations, but also have everything else open source. So if you contribute code back to Salt, it is all Apache 2.0. So you're not going to like contribute code back to Salt and suddenly it's only in the enterprise version. I mean, it's all open source and it's available for use. That being said, we do now have support offerings for just open source. So if you have 500 servers and you would like to have support, but you're just running straight open source, we actually support that now. So you can have support contracts for that as well. So yeah, for a long time we didn't. We required you to do enterprise to get support, but we don't at this point. Yeah. So the question was the difference between writing a formula and having everything be like in your top file or I guess in your file roots. So Salt formula, if you go to, we have a GitHub organization that we keep all of our Salt formulas in. And there's, I don't know, I think we're into the hundreds, I think, now at this point. So Salt formula is kind of a generalized, kind of a best practices way of doing something. So at this point, they're pretty much generally, they're all community supported. We do provide some support to that, but our community really has rallied around and worked on those. And it's so basically you can just clone that Git repo, or you can use GitFS on that Git repo. And so like most of them straight out of the box will give you an installation of, let's say, MySQL or something with some sane defaults. And then they're set up to allow you to pass in variables to configure that simply through like the pillar system, that type of thing. So anytime you have like a generalized thing, Salt formulas are a good way to look at that. So say you have a MySQL expert on staff and she has everything just tuned just right. Well, other people in your organization can use her Salt formula to do the right thing without having to be an expert with MySQL, for example. And so that would be kind of where, whereas maybe somebody else has, a light HTTP state that they just use, and so they would just stick that on their file roots on their master, and no one else really cares about it. And so they wouldn't necessarily make that like a public, or at least public within your organization. The good thing about using the ones on online as well that we have is that, again, you're using something that people have already gone through the pain of experience to get going. So, obviously you need to test them to make sure they work according to your needs, but sometimes it's a good way to get started on something complicated without having to do it all yourself. That's essentially what a Salt formula is. Yeah. There are 3 out right now. Actually, no. There's 4. They're all pretty good. So there's 2 by Joseph Hall, who is one of the original 4 co-founders or original engineers of Salt. One's like kind of like a getting started, Salt basics, and then he just released another one that's more advanced use cases. I haven't read the second one yet, but that just released. So it's Joseph Hall. I'm not sure what the name of the book is. Yeah, there's another great one that's written by Colton Myers. Cool. And then a former engineer from LinkedIn also wrote one as well. Drawing a blank. on the name of that. But there's like 3 or 4 books out, and yeah, we have some SaltAirs. We haven't done a lot of video tutorials yet. We do provide Salt training, both in our office, we can do it in your office, and we also do it remotely. So we have a remote video conferencing system that works really well for training as well. So those are really, and it's actually a really great training. Our founder was actually a trainer for Red Hat for a long time, and so his the training class. If you go to saltstack.com, they'll have some things on training. We have a guy in the back here that would love to talk to you about that as well. This guy in the green jacket. And I know I'm very biased, but it's actually one of the better trainings I've ever been a part of. I mean, you'll come out of it with a really good overview of everything Salt can do, as well as getting your hands dirty, doing all the configurations, and even extending Salt to an extent too. So you really come out with it's a great boost. In fact, when I was doing professional services, I would basically force them to do a training the first week we did stuff, because it just helped for them to like know what we were doing, because they had the training already. So it's a really good time. So. All right, I think we're out of time. I can stay around for a few minutes afterwards, but thanks everybody for coming. I appreciate it.